and basically no matches found. So the player did not deliver a correct recipe. So let's do another debug.log in here. Okay, so this is all of our logic. It looks a bit complex, but I hope this was easy to follow. When we see it in action, it all becomes a bit more clear. So all that's left is just calling this function from the delivery counter, so let's do that. Over here on the delivery counter, it accepts plates, it destroys plates, but before we destroy, let's go into the delivery manager, which means we need to access a reference. So again, we could add a serialized field, or in this case, it makes perfect sense to make this a singleton. So let's make it here, public static of type delivery manager, call it instance with a public get and a private set. Okay, then over here on awake, let's set instance equals this. All right, so now over here on the delivery counter, we can go into the delivery manager, access the instance, and deliver our recipe and pass in the plate kitchen object. Okay, that should do it. Let's test. All right, so let's look in the log to see what they are waiting for. So there are 2 cheeseburgers waiting, another mega burger, and a cheeseburger. So let's make a cheeseburger to deliver. So first of all, let's cook some meat. Let's slice some cheese. Let's pick up the meat before it burns, pick up the cheese, and we just need the bread. Okay, this is a valid cheeseburger, so let's deliver it. And there you go, the player delivered the correct recipe. Okay, great. Now let's deliver something that nobody asked for. Let's say just some meat. Actually, let's burn it just for fun. Alright, so there we have a bunch of charred meat, so nobody really wants this. But if we deliver, yep, there you go, player did not deliver a correct recipe. Alright, awesome, so over here everything worked. We have a bunch of recipes being generated. And then we have the logic so that when the player delivers something, it checks if the player delivered something correct or incorrect. So everything is great. All that's missing is obviously some nice UI, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to create a nice UI visual to display our waiting recipes. Okay, so our delivery manager is already working. We are randomly spawning some random recipes every once in a while. Now instead of looking at the console, let's add a proper UI. So for that, over here in the editor, let's go inside the canvas. And by the way, let's click on the button to unlock the canvas. And this is actually the first time we're using the regular canvas. Quite a while ago, we just created it. We didn't really set it up, so let's quickly do that. For the render mode, this one is meant to be a regular UI, so let's leave it on the screen space overlay. Then over here on the canvas scaler, instead of constant pixel size, let's go with scale with screen size. Then for the reference resolution, I like to use 1920 by 1080. And finally, I like to fully match with the height. Basically, this means that objects in the canvas will only be scaled if the height changes. For example, let's add inside just a quick UI image just to test. Let's look in the game view. So there you go, there's the image. Let's just put it on a different color. Okay, so there's the image. And note how if I modify the aspect ratio here, so let's say I put it on 5:4, there you go, the horizontal size of the window changed, but note how the element was not scaled. So I can put it even on free aspect, so really wide and does not change the size. Whereas if I modify this, if I modify the vertical size, the image does indeed get scaled up or down. Personally, I like the setup because it means that I only have to worry about positioning things horizontally. If the vertical part gets changed, everything gets automatically scaled. Okay, so great. So over here, let's go back into Full HD, all right, and let's get rid of the image, all right. Back in the scene view, let's quickly look at the canvas, so we can select the canvas, press the F in order to zoom out, and also we can press the 2D button up here to go into 2D mode. Okay, so here's our nice UI. Now inside the canvas, let's create an empty game object, call it the delivery manager UI. Then in the inspector, let's make it stretch to occupy the whole thing, so let's put 0 on everything. Okay, so this window now occupies the entire screen. Now inside, let's do just like we did a while ago for the plate icons, meaning let's make the template that we can then clone, but let's also put those templates inside of a container. So first of all, let's make the container, so a new empty game object, call it just the container. The reason why I'm going with this approach is because I also want to have other objects outside of here. If you remember how we did with the templates, we can actually go there and see. So let's go inside the prefabs, inside the counters. Actually, it's on the kitchen object, so let's go inside the plate. Over here for the template, basically we use the plate icons UI, this main canvas as the container. But if you remember how we did that, in order to make sure we didn't end up with duplicate icons, we always destroy the previous one when we spawned a brand new one. So every time we were cycling through the children of this object in order to destroy all of them except the template. So over here, we're going to use a container so that we can apply that logic only to the children of the container, and that way we can have other objects outside of the container. For example, outside of here, let's say we want some nice text just saying recipes in waiting. So on the delivery manager, let's make it a child of that one. Let's go into UI and let's make a text Mesh Pro. And this is the first time that we're using Text Mesh Pro, so this window pops out. Let's actually import the Text Mesh Pro Essentials. Okay, just let it import. Okay, that's it. We don't need the examples or extras, so let's just close this window. And over here on this window, let's name this the title text. Let's set the text to something like recipes waiting. Let's put it up there on the corner, so let's anchor it on the top left corner. Also for the text, I like to put it on a width and height of 0, but of course that makes the text really vertical. So then down here on the wrapping, let's just disable it. So there you go, looks like that, and let's put it over there on that corner. Now in scene view, we are seeing things different. So if you want to see what this looks like, just go into the game view, and over there, yep, we do see the recipes. Let's just make it in bold. So there you go, just some nice text. Okay, so that's our text. And then for the container, let's make inside the delivery template. So let's create an empty game object. Let's call it the recipe template. And for this one, we're going to want to anchor it to the top left corner. So with the template selected over here in the inspector, let's click, and we want to click up here. However, we also want to set the pivot. So let's make sure to hold down Shift in order to set the pivot over there. Okay, great. That's exactly what we want. So we want the template right on the corner. Then let's give it a size of say 250 by 100. Okay. Now inside the template, we just need two things. We want the name of the recipe as well as the list of all the ingredients. Although before that, let's actually make a nice visual for the background. So a new UI image for the background. Let's make this one stretch to occupy the whole thing. Let's put everything on 0. Okay, that's the background. Let's put it on a black with just a little bit lower alpha. Okay, that's good. Then for the name, let's make a text field. So inside the template, let's create another text. Call it the recipe name text. Then over here, let's put it a bit small, so on a font size of maybe just 20. Let's put it in bold. And let's also again put the width and height of 0. And over here, make sure to disable wrapping. Okay, so that's the text, so we've got it up there. Let's just anchor it to the top left corner. Okay, great. Over here, we can change the name to recipe. And then what we need is the icons down here. And for that, we're going to do pretty much the exact same thing that we did on plate. But before we do that logic, let's just get this basic setup working. So let's just position everything. So first of all, the container for all the templates, let's anchor it on the top left corner. And let's push it all the way over there. And for positioning them, let's use this time the vertical layout group. So inside, let's duplicate the template just to be able to see them. Okay, so that's pretty much what we want. We can actually set the width and height both to 0. And let's set the spacing to something like 30. Okay, so that's our basic UI. Now let's make the script to run this. So over here in our scripts, let's create a brand new C# script for the delivery manager UI. Let's go into the parent game object and let's attach the script. Let's open. Okay, so now here, first we need a field for the container and another one for the template. So let's do a serialized field, private transform for the container, and another one for the transform, and this is going to be the recipe template. Then let's do pretty much the same thing we did previously. So first of all, let's actually go on awake in order to hide the template. So game object set active into false. Okay, so first we hide the template. Then let's make an update visual function. So private void update visual. And for updating, we're going to do the exact same thing that we did. So first, let's cycle through the container and destroy everything except for the template. So do a for each transform child in the container. And if the child is the template, if so, then we're going to continue. And if not, we're going to destroy the child game object. Okay, so we have the cleanup. Now all we need is to cycle through all of the waiting recipes. So that means that over here on delivery manager, we need to expose our waiting recipe SO list. So let's go down here, make a function to do that. Public going to return a list of recipe SO, get waiting recipe SO list. And we just return the waiting recipe SO list. Okay, great. So now here on the UI, we can now go into delivery manager, access the static instance in order to get the waiting recipe SO list. So let's cycle through this. So do a for each recipe SO in the waiting recipe SO list. And for each of them, let's instantiate and let's spawn our recipe template, spawn it inside the container. And then we just need to set this to enabled. So let's grab the transform for the recipe transform. We grab this one, grab the game object and set active into true. Okay, so like this, the only thing missing is the text, but that's okay for now. Let's just see where we're going to call this function to update the visuals. And as usual, we want to be smart and write some good clean code. So let's not do the dirty approach of just updating this on every single update. Instead, let's only call this function when something actually changes. So over here on the delivery manager, let's just make some simple events. Say public event handler. Let's call on recipe spawned. And another one, call it on recipe completed. And actually, as soon as I add the event handler, which also add the using system, now here we have an interesting thing. We've got a nice namespace collision. It's telling us that random is an ambiguous reference between UnityEngine.random and system.random. That is because both these namespaces, UnityEngine and system, both of them have a class named exactly random. So the code here does not know which class we're trying to use. To solve this conflict, we really just need to be more specific. In this case here, we want to use the UnityEngine version, so let's just write the full name UnityEngine.random. And yep, that works. Okay, so now let's fire off the events. So first of all, the onRecipe spawns. Over here, when we spawn a recipe, let's invoke this event. So this event_tars.empty. And let's also get rid of the log. We no longer need that. Okay. Now we could also add the waiting recipe on the event_tars, but in this case we don't need it. Just firing the event is enough. And then down here, when the player delivers something, if the player delivers the correct recipe, we remove it from the list. And then let's fire off the event. So onRecipe completed. Let's invoke with this and event_args.empty. Okay, so we have the event, and down here we also don't need a log. Okay, so that works. And finally, over here on the delivery manager UI, let's just make a private void start. On start, going to delivery manager, access the static instance, and listen to both these events. So the spawned, and let's also listen to the other one. So delivery manager instance on recipe completed. When either of these work, let's just go and update the visual. So just like this. Let's also rename this because again, instance doesn't sound like a very good name. Let's actually rename this to delivery manager, and same thing up here. By the way, I'm using the Visual Studio shortcut Ctrl+RR in order to rename this to delivery manager. And finally, we also need to update the visual on start, just to make sure the previous ones do not show up. Okay, that's it. So like this, it should be working. We should be able to see no visual, and then as more are spawned, we should be able to see each one being spawned until the maximum. So let's see. Just over here in the UI, let's make sure to drag the references, so the container and the template, and let's hit on play. And okay, right away, actually it spawned one recipe, it spawned instantly. Then after 4 seconds, there you go, a second one. And after 4 seconds, we should be able to see, yep, another one. Now 4 more seconds, and we should see the final one. And now, no matter how long we wait, it should no longer spawn anymore. And yep, that works. All right, awesome. So the basic logic is working. Now let's handle the proper logic on the template. For that, like I mentioned previously, one approach would be over here. You could go and do a transform.find, find the actual recipe name text, then get the text mesh component and set it. That would work, but like I mentioned previously, that would be very dirty, not good at all. We should avoid using find at any time, and we should also avoid the individual logic from the total logic. So let's do it properly and make a proper script to handle each spawn template. So let's create a brand new C# script. Call this delivery manager single UI. Single just because it refers to a single recipe. And also right now we already have quite a few UI scripts. So let's organize our project again. So let's organize a new folder for the UI. And inside let's put all of our UI scripts. So delivery manager single, this one, the plate icons, and the progress bar. So let's put all of these nicely organized in the UI folder. Okay, so with the script, let's go into the recipe template and attach the script. Now let's open. And over here, let's begin by adding a field for our text. So a serialized field. And over here, it's also very important. For the text, we are not using the text inside UnityEngine.ui. This is the legacy text. It is not TextMesh Pro, so this is not what we were using. Instead, we want to use TextMesh Pro UGUI, which is inside TM Pro. So we need to go up here and add using TM Pro, and now we can use this type. And also make sure you're using TextMesh Pro UGUI and not TextMesh Pro. This one also exists, but don't mix these two. These are two very different types. If we go over here in the editor, and if outside the canvas, if I just create a new 3D object, a new text object, if I do that, then if we look over here in the inspector, we see this one is of type TextMesh Pro. Whereas for the ones that we're using inside the canvas, if we look, this is TextMesh Pro, it's a UI text. So these are the two different classes within TextMesh Pro. You have TextMesh Pro and TextMesh Pro UGUI. We're working on the UI, so we want this one. Okay, so we named this the recipe name text. Okay, that's it. Over here in the editor, let's drag our reference, all right. So in the script, let's make a function to set the recipe. So a public void, and let's call it set recipe so. And we're going to receive a recipe so. Then we just go into the recipe name text and we set the text to recipe so.recipe name. Okay, so that's pretty much it. Now over here on the UI script, when we instantiate our recipe transform, let's get component of type of our delivery manager single UI and call set recipe so and pass in the recipe so. Okay, so let's see if the name shows up. And yep, right away it does show up, so we can see that we generated a cheeseburger recipe and right now a mega burger recipe. Okay, great. So all that's left are the icons down here. So like I said, that is going to be yet another usage of our template pattern. So inside the recipe template, let's create an empty game object, call it the icon container, and then inside that, let's make the template, and template is just going to be an image, so we can just create an image straight away. Call it the ingredient image. Let's scale it with a size of 40 and 40. Let's put an image by default, just like that. And on the icon container, let's put the width of 0, height of 0, and let's put a horizontal layout group. Put it over there on the left side, and we can create a bunch more just to see how it looks. Okay, so that's pretty much it. Now over here on the single script, let's add a serialized field, private transform for the icon container, another one for the icon template. Then we do the same thing as usual. So when we set the recipe so, let's first of all clean up the container. So let's do a for each transform child in the icon container. And if the child is the template, then we want to continue and ignore it. If not, we want to destroy the child.game object. Okay, so that's the cleanup. And then let's do a for each kitchen object so in the recipe so.kitchen object so list. Second through all of this, let's instantiate our icon template. Instantiate it inside the icon container. So this is going to be the transform for the icon transform. Then as usual, we need to go into the game object, set active in order to enable it. And also let's go up here, make a private void awake, and on awake the icon template game object, let's disable it. Okay, we don't want the template to be visible. Okay, so we instantiate the template. We set it as active. Then since this one just has an image, we can just do a get component of type image. That's image, not image conversion. So image, so it's this one, the one inside unityengine.ui. So let's get this image and let's modify the sprite and set it to this kitchen object so.sprite. Okay, so that's it, that should do it. Let's test. Over here in the editor, let's just go into the template. Let's drag the container reference and the template reference. And let's also rename this, instead of ingredient image, put icon template just to be a bit more clear. And we can get rid of the other ones or leave them, doesn't really matter. Okay, great. So let's hit on play and see. And yep, right away it does work. So we can see a burger is composed of a burger and a bun. A salad, yep, there you go, some sliced cabbage and sliced tomatoes. Then cheeseburger, same thing as the burger with some cheese. And then another burger, let's just deliver until we see the mega burger. So let's deliver a cheeseburger, let's cut it. Get this, get some bread, place it in there, pick it up before it burns. That's a cheeseburger, so that one should vanish. And if there you go, it does vanish. Let's see if something else, not a cheeseburger, so let's keep doing until we get the mega burger just to see that everything works. So let's deliver a regular burger. Okay, now let's deliver a regular salad. Okay, just pick up like that, and drop it. Okay, let's see. And yep, there it is, the mega burger. Alright, great. So the visual logic is fully working and the delivery logic, all of it is working. So I can deliver the right recipes and get rid of them from the recipe waiting list, and more are spawned every time. Here we can see the name of the recipe as well as all of the nice icons. Okay, so with all of this, our game is really taking shape. Everything is very close to being done. One massive thing we're still missing is an obvious one, which is sound. So let's do that in the next lecture. Hey again, quick intermission. You're almost at the end, so once again, congrats for making it this far. This is the second secret callout. Go ahead, post in the comments a timestamp and a nice monkey emoji. It will be fun to see how many people make it to this point. By now you already know about the website. I hope it's been very useful to you, and you already know to ask any questions in the comments if you need help with anything. So all that's left for me to say right now is thanks for watching the course so far, and I really hope you've already learned a ton. There's only a bunch more lectures until we get to the final polished game, so let's continue on the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to add some audio to our game, starting with a really nice music track. Okay, so our game is already looking pretty good, but everything is still way too silent, so let's begin by adding some music. Adding this is actually extremely easy to do. In the included assets over here inside the sounds, we've got a really nice music track. I hired the musician to make this, it sounds really good. It's a seamless loop, so to add to our game it's going to be super simple. We just want a constant, never-ending loop. So let's begin by creating an empty game object, call it the music manager. Let's reset the transform, keep things organized, and let's add a component, and we want the component an audio source. Here it is, this one. Like the name implies, this one acts like a source of audio. You will note how by default on the main camera, down here, it already has an audio listener. So the source plays some sound and the listener listens to it. Now over here, we just need to set these fields. So for example, on the audio clip, let's make sure to drag the music audio clip. Okay, great. Next over here, let's enable play on awake. We want it to start playing right away. And for this track, we do want to enable looping. Okay, great. Then for priority, basically Unity has a limit to how many sounds can be played at once. If you play too many, then some sounds won't play. And which ones do play is all based on priority. We always want the music to play, so let's put this one on max priority. Then for the volume, later on we're going to make a proper option screen to handle this. But for now, let's put it on something like 0.4 or 0.5, just to make a nice background track. Then we have here the spatial blend. For this music track, we want it to play the same regardless of where the camera is. So let's make this all the way fully a 2D sound. Okay, and that's it. We don't need to play around with any of the other settings. And just like this, if we are on play, and yep, there's the music. Now if you're not hearing anything, make sure that on the game view, first of all, that the game is actually selected. Make sure the scene is in focus. So over here I can move around, so the game is in focus. Then on the game view over here on the top right corner, make sure this sound icon is toggled. If not, then everything is muted. And also again, make sure, like I mentioned on the main camera, that it has the audio listener component. With all of that, yep, you should be able to hear the music. Now this song is playing and it will loop forever, just like we wanted. Personally, I really like how it sounds. I'm really happy with what the composer made. It perfectly matches the vibe of the game. So it really is this simple to add some music to the game. Let me just point out one thing also related to sound. One of the things you can make is an audio mixer. So for example, on the project files, let's create a brand new, and let's find over here the audio mixer. So there you go, here is an audio mixer, then you can double click to open up the audio mixer window. And then over here you have the master node, and then you can create multiple groups. So let's create a brand new group for something else. And then you can play around over here with the effects, with the volume, all kinds of things, all kinds of effects, everything. Then for each sound where you have the audio source, over here note how you have an output. And for this output, you can set it to play on the master, so it plays on everything, or set it on just one individual group. So with this, you could assign a group to one individual type of sound effect or the music or so on. Maybe you could even have your music split into multiple stems. So there's lots you can do, but for me, I'm not an audio engineer. Audio is probably the part of game development that I know least about. I just stick with the absolute basics. But if you want to learn more, definitely look into the audio mixer. This is an extremely powerful tool. But like I said, for me, I don't know how to work with it, so I'm just going to stick with the basics. So on the output, let's revert back into none, close the audio mixer, and get rid of this. And there it is, the music is playing, and it all sounds really nice. Alright, so here we very easily added some music to our game. This lecture is actually super short because it is genuinely that simple. Now the next thing that we need is going to be a little bit more complex, and that is adding sound effects. So let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to add some sound effects for our game. Okay, so previously we already added some really nice music, now let's add a whole bunch of sound effects. In the project files, if we go inside the assets over here, we've got all kinds of sound effects. Basically I hired a really nice sound designer to make all of these, and I think they all sound really great, so let's add them to our game. Now when it comes to sound effects, there are two main ways to play a sound. One is just like we did for the music, so we can create a game object, add the audio source component and play it. That's one approach, but that basically requires pre-preparing the sound objects. So there is another simpler way that just requires one line of code. So let's begin by making a sound manager game object. So a new empty game object for the sound manager. Let's reset the transform. Now let's make our script. So let's go in the scripts folder, create a brand new C# script for the sound manager. Let's attach the script and open. Okay, so now here let's make a function to play simple sound. So let's do a private void, just call it play sound. And over here, the way we play sound through code is actually super simple. We just go inside the audio source class. And in here, there's a static function, play clip at point. This, as you can see, takes an audio clip, a vector3 for the position, and finally a volume. So basically, it won't play that sound on that position. By default, Unity already has 3D sound, so if you play the sound on the left or the right side of the camera, it won't play in the correct place. Also for the volume, the further away it is from the camera, the lower it will be. And if we don't want the 3D sound, we can just play directly on top of the camera position. Okay, so in this function, let's receive our arguments. So for the audio clip, it's going to be our audio clip. Then let's receive vector3 for the position. And let's also receive an optional one for the volume. Let's just default this to 1F. Okay, so here we just pass this in into our function. So the position and the volume. Okay, great. So now let's call this nice function. And for example, let's start with a simple one. So let's start with the delivery sounds. So over here on the delivery manager script, down here we have the logic for delivering a recipe. And over here we know when we completed a successful recipe or when we failed and the player delivered a wrong recipe. So this is where we want to play some sounds. And again, here we have yet another very important clean code question. We could technically call the play sound function directly from here. That would work, but of course that would make this class tightly coupled with the sound manager. For a simple game on this scale, that approach can work, just play sounds directly from the logic code. However, again, to make things properly, we should really separate the logic from the sound, just like we separated the logic from the visuals. So instead, let's not call the sound directly from here. Instead, let's make two more events. So let's make one on recipe success, and another one on recipe failed. Okay, so now let's fire off these events. So over here we have the success, so on recipe success. And if we get down here, then we have a fail. So on recipe failed. Okay, great, we have two events. Now back here on the sound manager, we can just listen to those. So let's do a start, go into the delivery manager, access the instance, and listen to the on success and on failed events. So listen to that one, delivery manager, instance, on recipe failed. Listen to both of these. Again, let's write some good clean code. So let's rename this one instead of instance. Let's put it delivery manager. And same thing on this one. Also name it correctly, delivery manager. Okay, great. So now when you have this, we want to call play sound. And now I want to pass in a reference to the recipe failed sound. So technically one approach would be up here to add a serialized field for an audio clip. That would work. But since we've already done that so many times in this course, here let's use a different approach that I also like to use. Let's create a scriptable object to hold a reference to all of our sounds. So similar to how we define the scriptable object to hold all of our recipes. Let's just comment this out just to make sure the code compiles. Okay, great. So back here in the editor, let's make a new scriptable object type. So let's create a brand new C# script for the audio clip refs scriptable object. Now here, let's make this a simple scriptable object with a create asset menu. Okay, so now for the fields, if we look in the S over here, the audio designer that I hired actually made several variations for each sound. So we've got multiple chops, multiple delivery fails, and so on. So back in the code here, instead of storing a reference for a single audio clip, let's store an array for all of them. So we have the chop, then we have all the others, so let's just add all of the references. So there's a chop, there's the delivery fail, then we have delivery success, then we have footsteps, then the object drop, then the object pickup, then we have the stove sizzle, although this one is just one, then we have the trash, and finally we have the warning. Alright, so these are all of the sound references we're going to use. Back in the editor, let's just create the object. So on the scriptable objects, let's create a brand new one. Let's make it of audio clip refs SO. Just name it audio clip refs SO. And over here, let's just drag the references. So let's use that quick Unity tip in order to unlock the inspector. Now I can select all the chops and drag them. All delivery fails, drag them. Delivery success, drag it. Then for all of the footsteps, After that are all of the object drops, then the pickups, then we have the sizzle, which is just one. Finally, we have the trash and the warning. Okay, those are all the references. So our scriptable object now has all of the data we need. Let's unlock the inspector, okay? And back in the code here on the sound manager, let's make another version of this function. So let's make one play sound, except instead of receiving an audio clip, it receives an array of audio clips. Then basically we just call the other function. So we call the other play sound function and pass in an audio clip from this array. So let's actually rename this. So audio clip array. And let's pass in an audio clip from here. So do a simple random.range between 0 and the array.length. Pass in the position and the volume. Okay, so just like this, now all we need is a reference to our scriptable object. So a serialized field, private of the audio clip refs.so. Okay, we have this. Then here in the editor, let's just assign the reference, so the audio clip refs. Okay, great. And over here, when we have the recipe failed, let's go into the audio clip refs. And let's pick up, this one is delivery fail. And then the other one is going to be delivery success. For the position, let's just default to the camera.main transform.position. So like this, the sounds will play exactly on top of the camera. Okay, so let's test and see if it all works. Okay, so here we are, and let's do a wrong delivery. Now, quick warning if you're following along, or if you're just watching the video, this sound will probably be way too loud, but let's test. So if I just pick up the plate and I just deliver an empty plate, yep, there you go, there's the sound. And now if I deliver a correct one, so someone wants a salad, so let's cut a nice salad, chop that, chop this, pick up the plate, pick up that one and that one, deliver the correct salad, and yep, there you go, it does work. Alright, great. So the sound effects work, they played perfectly, but they're a bit too loud. Basically that's because these sounds were designed to be played in the world rather than on top of the camera. So when we play the sound, let's actually play it on the position of the delivery counter. Here is the delivery counter script. And based on our design, we're only going to have a single delivery counter, so we can just make this a singleton. So as usual, public static of type delivery counter, call it instance, with a public get and a private set. Then on private void awake, let's just set the instance equals this. Okay, so now over here on the sound manager, we can just grab delivery counter, and we just go into delivery counter and grab the static instance. And then for the sound position, we can just go into delivery counter, access the transform.position. Okay, so just like this on that one and on this one. Okay, so let's test, now it shouldn't be as loud. Okay, so here we are, and let's do a wrong delivery. And yep, it does work. Now let's do a successful delivery, so let's make a nice cheeseburger. So grab some cheese, slice it, grab a plate, just need some bread, and deliver it. And yep, there you go, it worked. Alright, awesome. Okay, so this is really it. This is how we're going to play our simple sounds. Now there are some that are going to require more logic, like the footstep sounds and the stove sizzle. But first, let's begin by adding the simple ones. So let's begin with the chop sounds. This is super simple. We just need to go over here onto the cutting counter, and actually we already have the onCut event that we made previously. This was used to spawn the visual, so we can also use it to spawn the sounds. However, there's actually one difference. We're going to have multiple cutting counters, and this one, as you can see, this one is not a static event, meaning each different counter is going to have each list of listeners, and we really don't want to have to subscribe to every single one of the counters individually. So what we can do is, instead of making it a regular event that belongs to each instance of a cutting counter, we can make a static event which will belong to the entire class. But we still want to leave this one just for the visual, so let's do another one, a public static event handler, and let's call it on any cut. Basically, for any static events that belong to any object type, I like to add the keyword any. We're going to fire this event when any cutting counter is going to trigger a cut action. So where we fire this event is exactly the same thing. So over here we've got the onCut, let's do the exact same thing. So on any cut with this and event args.empty. Okay, so we have our nice static event. Now over here on the sound manager, let's listen to it. So let's go into the cutting counter. Again, we're going to access through the class name, and let's listen to the on any cut event. And over here, let's just play the sound. So let's play the sound. Let's go inside the audio clip refs.so, and let's grab the chop sound. Then for the position, We want to know who fired this event, and by following the C# standard, over here we already have the object sender. So we know this was the object that fired this event, and we know this is going to be of type cutting counter, so we can just get cutting counter, and we just grab the sender as a cutting counter. Okay, so we have this, and then over here, very simple, access transform dot position. Okay, that's it, great. That will play the cutting sound on that position on that cutting counter. Okay, great. Now let's handle the player picking up something. And for that, let's go over here onto the player class. And the way we set up the kitchen object parent system is actually already perfect for this. Down here, we have a function. So if we scroll down, yep, this function, set kitchen object. This one is called whenever the player receives a kitchen object, which means really when the player picks up something. So if this kitchen object is not null, then that means the player picked up something. So let's do that. So up here, let's make the event. So a public event handler, call it on picked something. And then down here, just do a test. So if the kitchen object is not null, so if the player did pick up something, then let's just fire off this event. So just do our usual invoke with this and event args.empty. Okay, so that's great. Then on the sound manager, let's just listen to it. So let's go into the player class. Let's access the static instance and let's listen to the on picked up something event. And again, let's rename this to a proper name. So player on picked something. And over here, let's just play the sound. And for the sound, go into the refs and grab, in this case, the object pickup. And for the position, let's just go player dot instance and grab the transform dot position. Okay, that's it. Next for item dropping. Now we can only drop items on a counter. So over here we have the base counter class. And again, we have the same thing. So we have the set kitchen object. And again, the same thing as with the cutting counter. We don't want to be required to listen to every single counter. We just want to listen to one event. So let's make it up here. So a public static event of type event handler. And let's name it on any object placed here. And then down here, when we have the set kitchen object, we do the usual if kitchen object is not null. If so, then let's fire off this event. Okay, great. And on the sound manager, let's listen. So go into the base counter on any object placed here. When that happens, play the sound. And let's go into the audio called prefs. And this one is the object drop, so that one. And for the position, let's do the same thing we did. So we cast the base counter equals the sender as a base counter. And then we go into the base counter and let's grab the transform dot position. Okay, so we just need one more special counter type. Here we have the trash counter. And this one, it never really changes the parent. It just destroys the object. So over here on the trash counter itself, let's fire off an event. But again, let's make it static, even though we're only going to have one trash, but make it static just to be able to support multiple. So public static event handler on any object trashed. And then over here, just fire off this event. So invoke with this and event args.empty. Okay. So now if we go into the sound manager and over here, once again, the trash counter on any, not the on any object placed, but on any object trashed. And on this one, let's do pretty much exactly the same thing. So let's copy this. The sound is going to be the trash sound. Instead of a base counter, we could just cast it to a base counter, but let's make it proper. So let's make a trash counter as a trash counter, and this is a trash counter. Okay, great, that's it. So these are all of our basic simple sounds. As you can see, all the logic is super simple. So let's test and see if it all works. Okay, so first of all, let's pick up an object. So if I go into a container and I pick it up, and if there you go, there's the sound. Now if I drop it somewhere, and if there's the sound. Now for the trash, pick it up, drop it on the trash, and if there's the trash sound. Okay, great. Then also let's check out the cutting. So if I pick up some cheese, drop it there, and cut, and if there you go, got a really nice cutting sound. Okay, so far so good. Now let's handle the more complex ones, starting off with the stove. For this one, the sound is meant to be looping, but only when the stove is on, so we don't want to just play once, but play and stop playing depending on the state of the stove. So for this one, instead of spawning the sound through code, let's actually spawn it on the object itself. So let's go inside the stove object. Let's go on the stove counter and open up the prefab. And inside this prefab, let's create a brand new empty game object, name it sound. Let's reset transform, make sure it's on 0, 0, 0. Okay, great. Now let's add an audio source component. And for the audio clip, let's use the pan sizzle. Let's make sure to not toggle play on awake, but we do want it to loop. And let's also make it a 3D sound. Okay, so that's the basic setup. Now to control this, let's make a script. So let's go into our scripts folder and let's create a brand new C# script. Call it the stove counter sound. Let's attach the script over here and let's open it. So now here first let's grab the audio source component. So we've got a private audio source for the audio source and just go on awake and audio source equals get component of type audio source. Okay. Then we're also going to need a reference to the stove counter. So let's add up here a serialized field private of type stove counter for the stove counter. Then back in the editor, let's drag that reference. All right. Now on the stove counter, over here we already have the states and we have the onState change event. Again, the same one that we used to modify the visual. So on the sound, let's do pretty much exactly the same thing. Over here, let's do a private void start. And on start, let's go into the stove counter and listen to the onState changed event. And basically, when this changes, we want to check if it's frying or fried. If so, then we want to play the sound. If no, then we don't want to play it. So let's define a bool, call it play sound, and we're going to play if the state equals we are frying or the state equals that it is currently fried and about to burn. Okay, then if we have a play sound, then let's go into the audio source and call play. And if not, then let's go into audio source and call pause. All right, so that's it, pretty simple. Let's just make sure to save our prefab, go back outside, and let's hit on play. And okay, for stars, there's no sound playing. Now if I pick up some meat and I drop it on there, and if there we go, there's the sizzling sound and continues going, and now it is still sizzling, but if it burns, it should stop. So if I go, and if there we go, the sizzling sound stopped. All right, awesome. So let's take this one out. Let's actually trash it. Now let's pick up another one, let it cook. And once it's cooked, pick it up, and there you go, the sound does stop. All right, awesome. So we just have one more final sound remaining, that's the footsteps. By the way, the warning sound is going to be added during the polish lecture. For the footsteps, we want very much the same thing that we did on the stove. So we're going to want a script to handle that logic. But this time we don't need an audio source on the player, we're going to use the same play method as the other ones. Let's just make a script to run the sounds, so let's make a new C# script for the player sounds. Let's go into the player game object and attach the sound, okay. So here let's first grab the player reference. So private player, and on private void awake, let's get component of type player and assign it to the player, okay. Then for the footsteps, basically we want to play them every certain amount of time. So let's do up here a private float for the footstep timer, another one for the footstep timer max, and let's say we want to play, say, 10 times per second. Then we do a basic update, and on update, footstep timer, countdown by time.time, and if the footstep timer is under 0, then let's reset it, so set it to the maximum, and it's in here that we're going to play the sound. So now here we have two options. We can fire an event here, and we can listen to it on the sound manager, so exactly the same thing that we've been doing previously, or we can just trigger the sound directly from here. Doing that will mean that this class is tightly coupled with the sound manager. Usually we want to avoid tight couplings. However, in this case, the player sounds class, this one is really only meant to exist alongside the sound manager. So in this case, it's perfectly fine to tightly couple them. So let's play the sound directly from here, which means we need a reference to the sound manager. We could make a serialized field or just make this a singleton, so let's do that. So a public static type sound manager. Name it instance with a public get and a private set. Then on private void awake, we just set the instance equals this, okay? So then over here we can just access it. So just go into the sound manager, access the instance, and we call play sound, which we actually need to make public. However, this function also takes a reference to the audio clip array. So that means we need a reference to the audio clips. So again, we have multiple options. We could add over here on the player sounds, add a serialized field for the footstep sounds, or we can just make a specialized function over here on the sound manager. Both options can work just fine. Let's go with the second one just to be different. So just make here a public void play footstep sound. We're just going to receive a vector3 for the position, and then we just call play sound. Let's go into the audio clip ref.sso, and let's pick up the footsteps and play it on this position. And let's also receive the volume. Just appear a float for the volume. Okay, so that's great. Now we just need to call this function. So over here on the player, instead of calling play sound, let's call the other one play the footstep sound. Then for the position, that's the player transform.position. And for the volume, I just exposed the volume just in case you want to make the footsteps a bit more silent or not. But for now, let's begin with 1F and then see if that's way too loud. As usual, instead of using magic numbers, let's define a float for the volume, put it at 1F, and over here use the volume. Okay, great. However, you might be noticing an obvious issue here. Right now, this is going to play non-stop. Obviously, we don't want to do that. We only want to play footstep sounds if the player is actually moving. So this is pretty simple. We just need to ask the player if it is moving. And we already did that, so player is walking. So if the player is walking, then we play the sounds. If not, we don't. Okay, that's it, so let's test. So here we are, and if I'm standing still, there's no footsteps. Okay, that's great. And as soon as I move, yep, there you go, we got some nice footstep sounds. Alright, great. So with all of that, we added all of our sounds. Now here, note how we mostly use this method of going into the audio source and using the play clip at point function. This one is great because it is so simple, but it does have limitations, specifically with regards to all of the options. If we look on the audio source component, here we have all these options, so you can use an output, use an audio mixer like we saw in the previous lecture. We can play around priority, play around the pitch, make it 2D or 3D, play around over here with how the sound falls off. So tons and tons of options that you can't really access if you use that simple function. So one approach, if you needed these options, you could make each sound a prefab, so make a prefab for each different audio clip, and then instead of calling that function, you would simply instantiate that prefab to spawn that audio. So you've got lots of options depending on how complex you want your sound to be, but for a simple game and for simple sounds, this one line of code is super simple. Alright, so here we have added sound effects to our game. That coupled with the music that we added previously already makes everything sound so much more alive. It's really starting to look like a proper game. The one thing we still don't have is some kind of game start and game end scenario, so let's add that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, let's add a simple beginning state to our game. So right now we can play the game. All of the mechanics, everything works perfectly, it's all been implemented. However, in the beginning of the game, it just starts right away as it loads. There's no start, no countdown, no time for the player to get ready. So let's sort that out with a simple countdown. Let's begin by making a general game manager script to handle all of our general game states. So let's create a brand new C# script. And now here you could use the name game manager, so you could use this name. However, for some reason, Unity likes to add this custom icon when a script is named exactly Game Manager. Personally, I don't like this. I don't want it to be a different icon. I want this script to look and behave just like any other one of my scripts. So personally, I don't like this, but if it doesn't bother you, then go ahead, use it. Doesn't really change anything, just a visual. But in my case, I prefer to give it a different name, so sometimes I call it Game Handler, or other times just something related to this game, like for example the Kitchen Game Manager. And just like that, it won't have that custom icon. Just need to go inside and rename this to Kitchen Game Manager. Okay, save the script. And alright, now let's make a game object to run it. So a new game object with the same name. Let's attach the Kitchen Game Manager and reset transform. Okay, let's open. Now here we're going to define all of the various game states that our game can be in. So for that, let's define an enum. So a simple enum, call it state. And for the various states, let's say we are first of all waiting to start. Then we are on countdown to start. Then the game is playing, and then we have a game over. Okay, so these are our states. Let's do a private void awake, and on awake let's set the state, so we need to store a state for our state. And on awake we set the state equals, and let's begin on waiting to start. By the way, the point with this waiting to start state will also be very important in the next video covering multiplayer. Basically, we're going to wait until everyone is connected before we start the actual countdown. But over here for now, we're just going to wait a little bit on the waiting to start. Then we're going to trigger the countdown, and then after some time, trigger the game playing state. So pretty much all of these states are going to be time-based. So let's make a simple timer. So a private float for the waiting to start timer. Let's begin on something like 1F. So we just wait for 1 second. Then let's make a private void update. And let's make a state machine just like we've done previously. So do a switch on our state. In case we are on state.waiting to start. If so, then let's go into the waiting to start timer, count it down by time.delta-time. Then if the waiting to start timer, if it is under 0. If so, then let's move into the state, equal state dot, let's go into the countdown to start. Okay, so that's it, and the other states are going to be pretty much exactly the same, so let's just copy this. So we have the waiting to start, then the countdown to start, then we have the game playing, and finally we have the game over, and that one doesn't have anything, so just like this. Like I said, we could reuse the same timer, but let's write our code nice and proper, so let's make different timers for each. So let's make 3 timers. So we're going to have the countdown to start timer. So countdown. For this one, let's default into 3. So we're going to wait 3 seconds before we start. And then the game playing timer. And for this one, let's put it something short just for testing. So let's put it just test. And then down here, let's just use them. So on the countdown, let's count down this timer. On the game playing, count down this timer. When the countdown ends, we go into game playing. And when the game playing ends, we go into game over. Alright, so that's our super basic state machine. Just a bunch of timers, super simple. Let's do a quick log just to see. So over here, just a debug.log. And let's just print out the current state. Okay, so just like this, let's test. And yep, right away we are waiting to start. After 1 second, going to countdown. Then after 3 seconds, going to game playing. And now if we wait for 10 seconds, after 10 seconds, we should be able to see just a little bit. And yep, there you go, we've got our game over. Okay, great. All the logic is working. Although we actually didn't change anything. Technically the game right now is on a game over, but everything still works the same as previously, so I can still play, I can still do everything. So let's sort that. When we are in any state other than the game playing state, we don't want the player to be able to interact with anything. We want to leave it movement, because that's usually nice and fun, but we don't want it to be able to interact, pick up objects, or do anything, so let's do that. Basically over here on the game manager, let's just expose a function, so public bool, let's call this is game playing. Then over here, pretty simple, just return if the state equals state.gameplaying. That's it. So now we can go into the player script. So over here on the player script, let's go down into the interaction function. So over here we've got the interact alternate and the interact. And on both of these, basically let's just ask if the game is in the game playing state. If so, we want to interact, but if not, then we don't want to do anything. So to access the game manager, we could add a peer serialized field, or as usual, let's just make a nice singleton. So peer public static of type kitchen game manager, the instance, make a public get and a private set. Then down here on awake, let's set the instance equals this, okay? So now over here on the player, let's just go into the kitchen game manager, access the instance and test is game playing. And we're going to do an if the game is not playing. So if we are not playing, we want to stop this, so let's just do a return. So if the game is not playing, the code is going to stop executing here, and same thing on the interaction. So just like that, we won't be able to interact with anything once we are not in the game playing state. Okay, so here we are, waiting to start. Nope, I cannot pick up anything. Countdown to start. Nope, I can't. And as soon as we go into game playing, yep, now I can't interact, so I can cut a bunch of things. And as soon as it goes into game over state, there you go, currently in game over state. So now if I try to interact, nope, can't do it. Okay, awesome. Everything works perfectly. So in terms of logic, this is really it. There's nothing else we need to do. But of course, right now the player would have no clue as to why sometimes they can grab and sometimes they can't, so let's add a proper visual. First, let's add a visual to the starting countdown. So let's do that as a canvas element. So let's go inside our canvas, create an empty game object, name this the game start countdown UI. Let's press F to focus on the object, press 2 to turn this into 2D. Okay, so let's see. Now over here, we really just need a text object, so let's leave this one anchored on the center. Let's put the width and height both on 0, we don't need that. And then let's go inside, create a new text object, call this the countdown text. And then inside, let's just put a number, so just a 3. Let's put the width and height both on 0. Then down here, let's put it in bold on a really big font size. So let's say something like 250, okay, really nice big number. Then let's also put it centered and down the middle. Okay, that's great, we've got our nice big countdown number. Also, by the way, when using Text Mesh Pro, we can easily add a whole bunch of effects. If we look down here, we have the default Text Mesh Pro material, and over here we can add an outline, an underlay, and so on. So that's really great. However, there's one very crucial thing. When you want to add some effects, always remember that the effects are being applied to the material. meaning any text objects that are sharing this material, all of them will modify. So for the most part, usually you don't want to modify the default material. If you do, then everything using this default material will change. Like for example, I want to add a nice thick outline to this one, but over here I've got some regular text that is also using the default material. So if I now add an outline, and I increase the thickness, and if there you go, those also got an outline as well as this. And if I want to dilate and make it quite a lot bigger, there you go, all of them modify, because all of them are sharing the same material. So usually you don't want to modify the default material. If you want to add some kind of special effects, always make sure to create a brand new material beforehand. So over here, let's remove the outline, put it back on the dilation, and let's go up here to create the brand new material. First, we need to find our font. So over here on the font asset, we can just click on it and we can see it over here highlighted on the project window. So it's inside the Text Mesh Pro folder, the resources, fonts, and so on. So here is the default font. And inside this one is the font that we're using. Now in this font, there's a nice little arrow icon, and inside we can see the default material. So let's duplicate this material. Although it's important, make sure you duplicate the material and not the font. So with this material selected, I'm going to press Ctrl D, and there you go, it duplicates the material. And over here, let's give it some name. So let's say this is the material that I want to use for the start countdown. So there you go, just like this. Also, one very, very important thing, the name of the material needs to include the font name, otherwise it won't show up. For example, if I get rid of this, the Liberation Sans SDF, if I name the material just like this, and now I'll look over here on the countdown text, look on Text Mesh Pro, here is the drop-down menu for selecting the material, and over here note how that one does not show up. So it is extremely important, in order for it to show up in here, it needs to have the same starting name. So over here, if I rename this material, put Liberation Sans SDF and then the name, and now back in here, now look, and yep, now I do see my material. Okay, so that's great. And now over here, we can add what kind of effects we want, and it will only affect this one and not any others. Okay, so for this one, let's add a nice outline and let's make some nice thick numbers. So over here on the dilation, let's dilate by quite a little bit. Then for the outline color, let's put it maybe on a blue, something a bit like this. Okay, let's push it back just a little bit. Okay, I think that looks pretty good. Now, if you want, you could add even more effects to this. I made another video covering how to use custom textures in your font. Doing that, you can just import the font directly into Photoshop and edit it with all kinds of effects. For example, that method is exactly what I used in my game Hyper Knight to make the hit counter look really nice. I also have a tutorial specifically on that. So if you want even more custom text, definitely go ahead and watch those videos. But anyways, here we have our countdown text looking pretty nice. Now the number itself will be written through code, so let's do that. Let's go into our scripts, into our UI folder, create a brand new C# script for the game start countdown UI. Okay, let's select the parent object and attach the script. Now here, first thing we need is a reference to that text object. So let's add a serialized field, private. And again, remember what I mentioned a couple of lectures ago with regards to the types. So we want Text Mesh Pro UGUI, we want this one. So it's going to be our countdown text. And now for updating this text, basically we just need to know the game state, so we need to know when the countdown should show up. And as usual, let's use some nice events. So over here on the Kitchen Game Manager, let's fire an event whenever the state changes. So a public event handler. Let's call it on state changed. Okay, just like this, no need for the arguments. So let's go down here, whenever the state changes, let's just invoke this event. So invoke this event args.empty. So we change in there, and change down there. Okay, that's it. So now over here on the game start countdown, let's do a private void start. And on start, let's go into the Kitchen Game Manager, access the instance, listen to the on state changed event. As usual, write some nice clean code, so let's rename this to the Kitchen Game Manager. So when the state changes, we basically want to show this if we are on the countdown to start. So let's go here to the Kitchen Game Manager and let's make another function. So public bool is countdown to start active. And we just return if the state equals the state.countdown to start. Okay, so that's a nice simple function. And on the UI script, if the Kitchen Game Manager, if this one dot is countdown to start active, if so, then let's show, if not, then let's hide. So else, let's do a hide. So let's make these functions, so private void show, and a private void hide. And on this, let's just do the usual thing, so game object set active into true, or over here set it into false. And on start, right after we subscribe to the event, let's also hide it by default. Okay, so that's the basic logic for showing or hiding it. And now for the timer text. Technically over here, whilst inside the countdown to start, we could fire an event on every single update. That would work, but it would have some unnecessary overhead. So instead, another option is just make a function to expose it. So let's go here, make a public, return a float, get the countdown to start timer. And we just return the countdown to start timer, very simple. So then over here on the UI script, we can just make a regular private void update. And on update, go into the countdown text in order to set the text. And let's go into the kitchen game manager and let's get the countdown to start timer and just do a toString. Okay, so that's it, super simple. So on update, we're going to constantly update the timer. So let's see if this works. Back here in the editor, let's just make sure to drag the countdown text reference and let's hit on play. And okay, waiting to start, and after a bit, yep, there you go, there's the number, it's currently on countdown, and now the game is playing. So the show and hide did work, although the number seemed quite a bit odd. That's because over here on the settings, we have wrapping enabled, so let's just quickly disable this, and let's test again. So there we are, waiting to start, and there you go, there's our countdown, 3, 2, 1, 0, and there you go, game playing. Okay, so it did work. Now of course, as it comes to the visuals, it depends on what you want. For example, if you want to limit the decimals, you can use over here the toString. This one can include all kinds of string formats. For example, for displaying just 2 decimal places, you can add the string format f2. Let's see what this looks like. Waiting for the countdown, and there you go. Now it does show with 2 decimals. Okay, so this is one approach. Alternatively, another format you can use is number sign, point, number. And let's see this one. And yep, there you go, now it looks like this. So as you can see, there's lots of things you can play around with when it comes to the toString formats. But in our case, I don't really want any decimals, I really just want to see whole numbers. So for that, let's just seal out this number. So a mathf.seal, let's seal this one out, and then just do a toString. Okay, let's see. So wait a bit, and we got 3, 2, and 1, and there you go, the game is playing. Alright, awesome! So here we have our waiting to start and the countdown to start, all of that logic is working perfectly. Now the next thing we need is to handle the game end, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to handle the game over state. Now for the game over state, this is obviously a game design question. For example, you could make it so that each recipe had a timer attached to it and the player had to create that recipe within the time limit. Then if they failed enough recipes, you could trigger some kind of game over. Or for something more simple, let's just do exactly what we did for the game start. Let's just do a basic countdown timer. After the game is over, let's pop up a game over window and show how many recipes the player delivered. So let's do that. Let's go into our canvas and inside make an empty game object. Call it the game over UI. Then over here, let's stretch it to occupy the entire parent, like this. Now inside, let's begin by making a UI image. This is going to be the background. Let's put it in black with just a little bit of transparency. And let's also stretch this to occupy the entire thing. So just like this. Then let's make some text. So let's make a new UI text. Call it the game over text. And let's say just game over. Let's set the width and height both at 0. Then down here, disable wrapping, put it centered. Let's put it pretty big, so maybe 135. Put it a little bit higher. Then for some more text, let's duplicate this. Let's call this the label recipes delivered text. And over here we just say recipes delivered. Let's put this one a bit lower and quite a bit smaller. Say on 50. Okay, and also on this one, let's put it in bold and change the color a little bit. Okay, next let's make yet another text. This one is going to be for the final number. So let's call this recipes delivered text. And this one is just going to have whatever number of recipes we delivered, and let's put it over here and quite a bit bigger. Okay, so this is the game over window that we want. Also, quick note, like I mentioned previously, the sorting order over here on the UI is based on the order in the hierarchy. So for the game over, we want this one to show up on top of everything else. So make sure the game over is the last one over here on the UI. Make sure it is the bottommost child on the canvas. Okay, now let's make a game object to run this. So let's create a brand new script. Game over UI, let's go into the object, wait for the compilation, and let's drag the script. Okay. Now here, the only reference that we need is just for the text. So let's just make a serialized field of type text mesh pro u GUI. for the recipes delivered text. Here in the editor, let's just drag that reference, okay? Now let's make some show and hide functions and also show it just on the game over. So really, we're going to do the exact same thing that we did over here on the game start countdown. So let's actually copy exactly this. Let's go into game over UI, pass the exact same thing. Okay, so we've got the show and hide functions, we test. And then over here on the state change, instead of showing this one on the countdown, we want to show it on the game over. So let's go over here and just make another function. So public bool is game over, and we just return if the state equals the state.gameover. Okay, that's the function. So over here, if we are is state game over, if so, then we show, if not, we hide. Okay, the last thing we need is just for the text. So this is going to be the recipes delivered text. So we're going to set this to something, which really means that we just need to keep track of all of the recipes that have been delivered. So let's go here onto the delivery manager script, and let's just keep track. So just a simple int, so a private int for the successful recipes amount. And then whenever we have a recipe success, so let's go here into our delivery recipe function. Whenever we have a success, let's just increase this by 1. Okay, so that's it. Now we just need a function to expose this. So a public int for the get the successful recipes amount, and just return the successful recipes amount. Okay, so finally back here on the game over UI, let's just print it. So go into delivery manager, access the static instance, and get the successful recipes amount. And of course we need a string, so toString. Except for this one, this is never going to change after the game is already over. So let's not do this on update. That would be quite wasteful. So let's just do it up here. So as soon as we have the game over, we print the recipes, and that's it. Okay, so let's test. So here we are waiting for the timer, and let's wait and just wait 5 seconds for it to finish, and we should see a 0. So let's just make sure that works. So after a little bit of time, yep, there you go. We've got recipes delivered 0, okay. Now back here again, let's try to deliver some recipes now. So let's try to make a cheeseburger. Try to deliver that. Cut this one, pick up this one. Pick it up, put it in there, and okay, quickly. All right, good. And there you go, we've got a 1. All right, awesome. Everything worked perfectly. Let's just add one more final element. Right now, we cannot see what is the time left in the game, so let's add a nice clock element. So over here on the canvas, let's make another empty game object. Let's name this the game playing clock UI. And let's also put it behind the game over UI. So let's put it above on the hierarchy so that it shows up behind. In order to be able to see what we're doing, let's also just hide the game over UI, but only here on scene view. So let's click on the eye icon. Okay, so here we have our window. Let's just anchor it on the upper right corner. So let's put it somewhere in there. Then inside, let's create a new UI image. Call it the background. For the sprite, let's go with the circle sprite. So let's click on the eye icon to show all the default sprites, and let's use the one included with the circle. So you have this one. Let's also add a nice little outline. So let's put it on 2.2 with full alpha, and let's also add a nice shadow, just a nice visual. So on 5 - 5 like that. And for the color, let's also put it some kind of dark gray. Okay, so this is our background. Now let's duplicate this. So Control D, and let's rename this one the timer image. And for this one, let's give it a different color. So maybe something like a blue. So something like this, okay? And now over here on the image type, instead of simple, let's go with filled. Let's choose radial 360, okay, great. And now over here, we can play around with the fill amount, and this will be our timer. Then you can set it up however you want. For me, I'm going to choose to start from the top. So as it starts, the timer is going to count down until the end. Okay, so that's great. Now let's make the script to run this. So let's create a brand new C# script. Same thing, the game playing clock UI. And over here, let's just attach a script. So now all we need is reference to our image. So let's make a serialized field. Private image, let's make sure to use this one, the image inside Unity Engine.ui. This is going to be our timer image. Okay, like this. Back here in the editor, let's drag the reference, all right. Now that we have this, we need to ask the game manager to get the timer normalized. So let's go over here onto the kitchen game manager, and let's make a function to return just that. So a public float, let's call it get playing timer normalized, or game playing timer, actually, just to match the state. So get this one, and up here we have the playing timer. We just need to define a maximum in order to be able to calculate the normalized value. So let's duplicate this, call it the game timer max, and set this one to 10 and this one leave it like this. And down here when we change the timer, when we go into gameplay, let's set this one equals this.max. That way we only define the timer just up here. Okay, so with that, now down here we can do the compilation, so we can return the game playing timer divided by the game playing timer max. Except just like this is going to be inverted, because for the game playing timer, we're counting down instead of counting up. So all we need to do is very simple, just reverse this, so just 1 minus, just like this. Okay, great, so we have this function. And then over here on the clock, just go private void update. And on update, let's go into the kitchen game manager, the instance, let's get that, and we're going to use that on the timer image.fillAmount. Okay, that's it, super simple, let's see. Okay, here we are on the waiting to start. Alright, waiting, and as soon as we start, yep, there you go, there's the timer going, and we can see it constantly increasing. So it's at the halfway point, and just a little bit more. And there you go, yep, we've got the time over, and we have our game over. Alright, awesome! So over here we implemented a really nice game over state. We have a playing timer with a nice UI element, and when it ends we get a game over window showing a bunch of stats. Now with this working, the next task is to have some kind of main menu so we can play again after the game is done. So let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to make a super simple main menu and a loading system. Okay, so every game needs a main menu, so let's build one. Let's begin by making the scene, so let's go into our scenes and create a brand new scene. Call this the main menu scene. And okay, here's our default scene. Now over here, for the most part, we really just want some basic buttons, so nothing too special. So let's create a brand new UI canvas. And let's set it up as usual, so screen space overlay, yep. Then let's go with scale with screen size, 1920 by 1080. And let's match with the height. Okay, so there's our canvas. Now inside, let's make an empty game object, name this the main menu UI. Let's stretch it to occupy the entire thing, so 0, 0 on everything, okay. Now inside, let's create a brand new UI button. Let's name this the play button. Then inside for the text, let's say play. Let's size the button to be quite a bit bigger, so let's say 450 by 150. And on the text itself, let's put it in bold, on a font size quite a bit bigger, let's say 70. Then let's also change the color. Let's put the text in white and the play button over here, the normal color for the image. Let's put it on a dark gray. Then also over here on the button background, let's add a nice outline. Let's put it on full black, say something like 3:3. Then let's make a shadow, and for this one 5 minus 5. Okay, so that's our basic button. Let's just anchor the button, so choose the play button. Let's anchor it on the lower left corner, and let's push it just a bit like this. Okay, pretty simple. Now let's duplicate this one, push it a bit lower. Let's also make it just a tiny bit smaller, so just 120. This is going to be our quit button, so let's rename this to the quit button. And inside for the text, just say quit, and put a bit lower on the font size, okay, like this. Okay, so we have the two basic buttons that we need. Now let's make the script to run them. So let's make a script with the same name, so main menu UI. So let's go into our script UI folder, create new script for the main menu UI. Let's attach the script and open. Okay, so now here let's begin by making serialized fields for our buttons. So a serialized field, private of type button inside unityengine.ui. This is the play button, and then we have another one for the quit button, okay? Back in the editor, let's drag the references, so that's the play button and the quit button, okay? Now here in the code, let's add some listeners to these buttons, so let's do a private void awake, and on awake, let's go into the play button, and go into the onClick event, so the event when the player clicks on the button, and let's add a listener, and now we pass in the listener. Now over here, to do this, we can add a function, so we can make a private void play click. We can define a function kind of like this, and over here add it as a listener. So that's one approach. Or another alternative that personally I like to use is to use what is called a lambda expression. So instead of defining an external function down here, we just go up here and directly we define a lambda. So we open parameters to display the parameters for the function, which in this case we have none, so just open and close. Then we do a nice little arrow, and then we have whatever we want to be our click code. So both the code that I have here and the one that I have here, both of these are exactly the same thing. This one is called a lambda expression, which is also a type of delegate. Definitely go ahead and watch my video on C# delegates in detail. It's yet another extremely powerful C# feature. I find them especially useful, especially over here to setting the click listeners. There's no need to make another function, just use a lambda expression and that's it. So over here, I'm going to use that instead of an external function. Okay, so we've got the play, and then let's also listen to the quit. So on the quit button, the exact same thing. Okay, now first on the quit button, it's actually very simple. We just go into application and we call the quit function. This will quit the game. That's it, very simple. Although one note, if we actually test it like this, so here is the game playing, and if I click on quit, and nope, nothing happens. Now the logic is actually working. We can see visually that the button is changing state, so we are indeed capturing clicks. However, when the game is running inside the editor, calling that function, the application.quit, doesn't do anything. But if this were a full build, then clicking on that would indeed close our game. Okay, so now for the play button. For this one, it's also very simple. We just need to go inside the scene manager, which is inside Unity Engine.scene management. We just need to go inside of this one, and we call load scene. This function will load a certain scene, and for loading, we can either use the scene build index or we can use the scene name. Like I've mentioned several times, string names are horrible, although in this case the alternative using an int is also not very good. Just a number is very hard to read the code and be able to know what scene this is loading. So there's one better approach that I prefer to use, but first over here let's just use the index just for testing. So we're going to load the scene on index 1, so just like this. And then here in the editor, let's go into File and Build Settings. And over here we see the scenes in our build. Right now we just have the game scene. So let's just add our scene. So let's drag the main menu scene and drag it on there. And also let's make sure it's on the top of the list. Basically the first scene is the one that will be loaded as soon as the game starts. So let's drag it right up top, just like that. Then over here on the right, we see the index. So by loading the scene on index 1, we're going to be loading the game scene. Okay, so with this, let's test. So here we are, and if I click on play, and if there you go, it does load the main scene. Okay, great, everything is working. So this is the simplest way to do scene loading. However, this method does have one issue. It's not super noticeable in a game of this scale because it loads pretty quickly. But like this, note how when we click on play, there you go, everything freezes for a little bit while the game is loading. Like I mentioned, in this case the freeze is so small, so not necessarily an issue. But if the game was much more complex, then the player would be staring at a frozen main menu for perhaps 30 seconds, that would not be good. One way to avoid that is actually very simple. Basically, it's what I already covered in detail in the scene loading video. That video was made quite a while ago, but it's still very much up to date. Here we're going to do pretty much the same thing. So we first create the scene, just empty, just saying loading. And then from that scene, we load the final scene. That way the game stays frozen on a scene that says loading, which is much more clear to the player. So let's do that. First, let's make our scene. So inside our scenes folder, let's create a brand new scene. Call this the loading scene. Okay, let's go inside. And now in this one, we want this one to be fully black. So let's go into the main camera and scroll down over here under environment. And instead of rendering the skybox, for the background, let's go with a solid color and let's go with full black. Okay, there's our black main camera. Now let's make a canvas. So a new UI canvas. Let's set it up as usual, so scale with screen size, 1920 by 1080, and match with the height, okay? Then inside, let's just make a simple text object. So just say text, then over here, let's say just loading. Let's put the text width and height on 0, put it on bold, let's make sure to disable wrapping, and push it over there on the side, and maybe increase the font size by a little bit. Okay, there you go, we have our very basic loading screen. Now we're going to load this scene, and then whilst on this scene, we're going to load the final scene. Although also one very important thing related to loading scenes is you need to remember the lifetime of the objects. Regular game objects, like for example the ones that we see here in the hierarchy, these get destroyed when you do a scene change. So for the goal that we're trying to achieve, we need to load this loading scene, but then also somehow transfer data so that the loading scene here knows which one is the final scene. Now you might think that over here on the main menu we could create a game object, attach a script that would hold the reference to the final scene, but like I said, game objects get destroyed as soon as we load the loading scene. So for transferring data between scenes, we can't really use a regular script on a regular game object. Now one approach is to use the don't destroy on load. This is a Unity function that helps you stop a particular script or a game object from being destroyed. That way the object won't persist through scene changes, so that's one option. But another option that I prefer is very simple. Let's just make a loader class. So let's create a new C# script, call this loader. And over here, let's go ahead and make this class a static class, and we are not going to extend mono behavior. So just like this. Basically, by making it static, it means that this one is not attached to any specific instance of an object. This class cannot be attached to any object and cannot have any instances constructed. Then inside we can add static functions in fields, like for example a static int for the target scene index. So now this field, we could set this field from over here on the main menu UI, and when we would load, we would not be resetting this field. Also here I should point out one quick thing. You can make fields static without making the entire class itself static. Making the class static is just a good approach if the entire thing, if everything in this class is also meant to be static. If you don't make it static, then you can have regular fields here. You can have both static and non-static, whereas if you make this static, then you're going to have an error because you cannot have non-static fields. So this is another clean code thing. If it's only meant to contain static logic, then make the class itself static. Okay, so we have a static field for our target scene. But as usual, we don't want this to be a public field. We don't want the main menu to directly write to this field. So let's make this class the only one responsible for anything related with scene loading. So instead, let's make a function, so a public static void, call it load. And for a parameter, let's receive a string for the target scene name. Then over here, we'll load the actual scene. So let's go into the scene manager and load the scene. And let's pass in the target scene name. Okay, that's it. And then over here on the main menu UI, instead of directly loading a scene, let's go into the loader and call load and pass in the scene name, so that's the game scene. Okay, so this is what we're going to do, that's good. Except it's obviously not good. Over here we're using string names, that's horrible, we should never use this. So let's avoid using strings as much as possible, and one simple way is to just define an enum for all of our scenes. So let's go here on the loader and let's define that. So a public enum, let's call it scene. And for all of our scenes, so we have the main menu scene, then we have the game scene and the loading scene. Okay, so then down here on this function, instead of receiving a string, we just receive a scene for the target scene, and we use the target scene. Although of course the Unity API does not support loading our custom enum, it has to be an index or a string, so the simple approach is just to convert this one into a string, that's it. So the only thing you need to make sure is that the enum values over here match the actual name on the actual scenes perfectly. So don't make any mistakes, keep it case sensitive, so don't do this, make sure everything matches perfectly. Okay, so just like this, everything should already be working the same as previously. So the main menu calls that, let's actually just use that. So let's use scene.gameScene. So on the main menu we do this, and on the loader we load the scene. Okay, let's test. Here is the main menu, and if we click and wait a bit, and yep, there you go, it didn't load the game scene. Okay, great. So everything still works the same as previously, except now all of the loading logic is inside of this class. And over here, let's load a loading scene in the middle. Basically, when we have this function to load a final scene, let's first off set this field. So this one, instead of being type int, let's make it of type scene. And this is going to be the target scene. And let's make it private, okay? So when we have this function, let's set that field. Although here, remember how this is a static class. So in order to access this field, we need to access it through the class name. Because over here, we also have a local variable with the exact same name. So let's access the unloader.targetScene and set it to the target scene. So again, don't be confused here. You can even use Visual Studio and put the cursor on top to see what object represents what. So you can see the unloader.targetScene is referencing this field, whereas this one over here is referencing the local field. So we want to assign the member field to the one that we received as a parameter. Okay, so we stored that, and then let's immediately load the loading scene. So scene manager, let's load the scene, and we're going to load the scene.loadingScene.toString. Okay, so we're going to load that. And now here comes the tricky part. If we do this, so if we load the loading scene and then immediately load the target scene, if we do it like this, it won't actually show the loading scene. We're calling these functions one right after the other, so it will load one and immediately the other. Basically, we need to wait at least one frame to render so that the loading scene is visible, and then we can load the final scene. So let's make a script to do a very simple job. Let's create a brand new C# script for the unloader callback. And now let's go inside the unloading scene. So this is important. Let's make this on the loading scene, not the main menu or the game scene. So over here, let's create an empty game object for the unloader callback. Let's reset transform, just keep things nice and clean. And let's attach the script, so the unloader callback, okay. And on this script, we want to basically just wait for the very first update. So let's do a private bool is first update. And we start it off as true, actually. So is the first update is true, then we do a private void update. So if it is the first update, If so, then let's set is first update to false. And we have the first update. Although technically I should point out that we don't really need this. We're going to load right away, so either way it will only run one update, but still I like to add this just to make the logic perfectly clear. Basically, if it is the first update, then let's call a function on the loader. So on the loader over here, let's make a function, public static void, call it loader callback. Okay, we have this function. So over here on the loader callback, let's just go into the loader and call the loader callback function. All right. So basically now here we have this function that is going to be triggered on the first update. So we know for certain the loading scene has been rendered. So it's over here that we want to load the actual final scene. Okay, that's it. Here we have a super simple loading system. Just make perfectly sure that the loader callback with the script, this one only exists on the loading scene. It should not be on any of the other ones. So let's test, and for that let's go inside the main menu scene. Okay, and now let's hit on play. Okay, so here we are on the main menu. Now if I click on play, and actually here's the thing that I forgot, so make sure you don't forget this. We need to add the loading scene to the builds in order to be able to load. So let's go up here into the build settings. Let's go into the project, drag the loading scene like that. Okay, so now let's test. So here we are on the main menu. Let's hit on play, and there's the loading scene. And after a bit, yep, here we have our game scene. All right, awesome. So with that, everything is working perfectly. All of the logic is working great. Now that it all works great, let's just make a nice proper visual for our main menu. So for that, let's go inside the game scene, and over here, let's copy a few things. So let's pick up the floor object, and let's also pick up the global volume with the post-processing. So let's copy both of these. Let's go into the main menu scene, and over here, let's paste both objects, okay? Now let's also drag some player visuals. So let's put this in 3D, go back down to the floor, and let's pick up some visuals. So let's go inside our assets on the prefabs visuals. Let's find over here the player visual. Again, make sure you drag the visual only. We don't want any logic components. And by the way, this is yet another great benefit of separating the logic from the visuals. Right now, it's super simple for us to place some players here because we have just the visuals completely separated from the logic. Okay, so on the visual, let's just make it look at the camera. Let's position a bunch more players. So let's duplicate this and put one to the side. We're going to move the camera in a bit, but now let's just place them. And in the included assets, there are a bunch of materials. So over here, we see the player body. Then we've got a blue, a green, and a red. Like I said, this first course is on making this game in single player, but the goal is to then make a second course after this one on converting this game into multiplayer. So that's why I included multiple colors. So let's just drag these. Let's go into this player visual, and on this one, make it blue. So on the head and on the body. Then on this one on the side here, let's make this one green. So green there and green on the head. And for the one behind, let's make this one the red one. So put it in red and in red. Okay, so we've got our nice 4 players. Now let's also add a camera. So we're going to have the camera kind of like this, kind of from below looking upwards. I think that looks pretty good. For that, let's use Cinemachine. So let's go into Game Object. Go into Cinemachine, and let's create a brand new virtual camera. Okay, like this, let's just push it up a little bit. Okay, so this is our nice composition. Now on the virtual camera, let's just go ahead and add some noise. So let's add basic multi-channel purlin. So let's do it just like we did when we first added Cinemachine. So let's use the handheld normal mild. And now let's just play around these fields, which by the way, you can do that while the game is playing. So let's hit on play. And over here, you can play around all the fields. Although actually defaults already look pretty good, but let's put the frequency maybe a little bit less and the amplitude maybe a little bit bigger. So just some nice little sway. And by the way, if you make any changes to the Cinemachine virtual camera and if now you stop playing, it will actually lose those changes. But over here on the virtual camera, there's this nice toggle, save during play. So if you tick this and now you exit play mode, and there you go, those changes were saved. Okay, great. Now let's just make sure to untick this so we don't accidentally modify. Okay, so here we have the basic visual that we want. Finally, there's also a game logo in the included assets. So let's just go into our canvas, into our main menu. Let's create a brand new UI image. Let's assign the logo sprite. Then let's just position it on that corner. So let's move it all the way up there. We can anchor it to the top left corner. And let's make it a bit bigger. And by the way, on something like this, if you play around this, it might get a bit stretched. So if so, over here on the options on the image, you can toggle this one to preserve the aspect ratio. So that way, even if you stretch, it won't actually be stretched. It will always be perfect. Okay, just like this. Okay, so here we have our basic main menu. It's a basic setup, but it looks pretty good. And with that, we have built a nice main menu alongside with a loading system. So I can click on play, it goes into the loading scene and then into the game scene. So that's great. The next thing that we need is some kind of pause button, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to add a pause button with a pause window that also has the ability to quit back to the main menu, and in doing so we're also going to solve some sneaky issues with loading. Okay, so here in the main menu we can click the play button in order to load the game, and yep, everything works, now I'm in the game. But now let's say I want to pause the game for a bit, or quit back to the main menu. Right now there's no way, so let's do that. Let's go here onto the game scene, and first let's handle the pause, and for that we're actually going to need some input. So let's first go inside our player input actions, let's open this, and then over here let's make a brand new action. Let's name it the pause. For the action type, let's go with button, okay, and for the bindings, over here let's go with escape. And actually, if we use the same method that we've been using, if we listen and press on escape, nope, doesn't work because escape just cancels it. So instead we need to use the search bar here, search for escape keyboard, just like this. Okay, great. Now again, as always, let's make sure to save the asset and wait for the compilation to happen. There it is. So now here on the game input class, let's listen to it and fire the event as usual. So go into the player input actions, the player action map, let's go into the pause action and listen to the performed event. And when this happens, let's fire off an event. So a public event handler. Let's go on pause action. And then down here, we're simply going to invoke this event. Okay, just like this. Now for listening to it, here's the question, where does that make more sense? Should we do it over here on the player script or perhaps over here on the kitchen game manager? I think over here on the game manager makes more sense since a pause is more related to the game itself rather than a specific action by the player. So let's add it over here. Let's first of all listen to the event, so let's do a private void start, and on start let's listen to it, so let's go into the game input, and we didn't actually make it a singleton yet, so let's do that. Over here let's make a public static game input for the instance with a public get and a private set. Then down here on awake, let's set instance equals this. Okay, there's our singleton. So now back in the kitchen game manager, let's go into the instance and listen to the on pause action event. And again, let's rename this to give it a proper name. So this is the game input on pause action. Okay, so here we have it. When we have this, let's call some kind of pause game function. So let's define this. Let's go to the end of the file here. And over here, let's make that function. So a private void, pause game, and over here, we're going to pause the game. Now for pausing, doing this is actually surprisingly easy. Basically, all of our logic is using time.time. For example, over here on the player script, we have our movement speed, yep, then we get the inputs, and over here on the handle movement function, yep, for the movement distance, we have move speed multiplied by time.time. Or another use case over here on the stove counter, we've got a frying timer, and how we count it down, again, is the same thing, time.time. Well, it turns out that behind the scenes, time.time actually already has a multiplier. When you access this, it is after that multiplier calculation. So over here on the pause game function, we can just go into time and we can modify the time scale. This one is the multiplier. So if we just put this at 0f, then that's it. This is going to pause all of the other delta times. So let's test. So here we are, pay attention to that and the countdown timer, and I press on escape, and there you go, everything pauses. The countdown timer pauses, over here the script pauses, and I can no longer move, nothing works, everything is perfectly paused. Alright, awesome, everything works. Except one problem, obviously right now we cannot unpause. If I press escape, it's not unpausing, so let's do that. Over here on the kitchen game manager, let's add a simple bool, so a private bool. Let's call it is game paused, and let's default it to false. Okay, so is game paused. And then down here on the pause game function, let's simply flip this one. So we set this one equals not this one, so that is going to flip that boolean. And then we check if the game is paused. If so, set it to 0f, and if not, then we're going to set the time.time scale back into 1f. Okay, so now this should pause and unpause. So let's actually rename this function. Since this is no longer just going to pause, let's rename this to toggle pause game. This is going to pause and unpause. Okay, so let's test. Okay, so here we are, everything is running. Now I pause, and there you go, everything freezes. I cannot move, the arrow is stopped, the countdown is stopped. Now I press again, and there you go, nice and resumed. All right, great. So all of the logic is working perfectly. The only thing we need is really just a visual. And as usual, let's separate the logic from the visuals. So let's go inside the canvas, let's go into the scene view, and inside the canvas, let's create an empty game object. Call it the game pause UI. Then let's stretch to occupy the entire screen, so 0 on everything. Okay, great. Now inside, let's first of all add a background. So a new image, name this the background. Let's once again stretch to occupy everything. And on the color, let's put it in black with just a little bit of alpha. Okay, just like that. Then let's add some text. So let's create a brand new UI text. Let's name it pause text. And in here, let's just say paused. Let's just make it big, so the width and height both on 0. Let's disable wrapping, put it center down the middle, and let's increase the font size by quite a bit and put it in bold. And let's also change the color, maybe a nice yellow, something like this. Okay, that looks pretty good. Let's just lift it up by a little bit. Now let's make a script to show this. So on the UI folder, let's create a brand new C# script. Call this the game pause UI. Let's attach it and open. Now here, let's do the usual thing. So let's make two show and hide functions. So a private void show, and then a private void hide. So on the show, game object set active into true, and on the hide, set it into false. Okay, that's it, pretty simple. Now we need to know when to show or hide these functions. So over here on the kitchen game manager, let's make two events to do that. So let's go up here, make a public event, event handler. And let's name this on game paused, and another one for on game unpaused. Okay, we have both events. Then down here on the toggle pause game, if we have this one timescale 0, that means we have pause. So let's invoke the on game pause, this event tars.empty, okay. And on this one, let's trigger the other one, so on game unpaused. Okay, we've got the two basic events. Now back here on the game pause UI, let's listen to it. And as usual, let's do it on start, so private void start. Let's go into the kitchen game manager, access the static instance, and let's listen to the on game paused, and then going to listen to the other one, so the instance on game unpaused. So listen to both of them. And as usual, let's write good clean code, so let's rename this. So kitchen game manager, and on this one, the same thing. So also the kitchen game manager. Okay, we have both. And when the game is unpaused, then we want to hide the pause window. And when the game is paused, then we want to show the pause window. And finally, of course, we want to hide it by default. So over here on start, after we add listeners, let's just hide it. Okay, so that's it. That should work. So let's test. So here we are. Everything is running. Now press the pause. And there you go. Got a nice paused window. Press again. And there you go. Everything resumes. Okay, great. So the last thing that we want is just a button over here to go back to the main menu. And let's also add a button to resume without having to press the hotkey. So over here, let's create a new UI. Let's make it a button. This is going to be the main menu button. Now let's make it quite a bit bigger. Okay, width and height of 30 and 80. Let's put this one quite a bit down there. And inside for the text, this one is the main menu. Let's put the color in white and the background for the button. Let's put this one in a dark gray. And let's also, just for fun, add a nice outline. And let's also add a shadow. For the outline, let's put it on full alpha. And let's put it on about 3.3. And for the effect on the shadow, 5 - 5. Okay, so that adds a nice outline and a nice shadow. And then for the text itself, let's put it in bold and raise it by just a little bit. Okay, just like that, looks pretty good. So this is the main menu button. And then let's also duplicate this. Let's make this one, rename it. This is the resume button. And inside on the text, let's say resume. Okay, we have our two basic buttons. So let's handle them in the script. So over here, let's add, as usual, a serialized field, private of type button. So that's inside unityengine.ui. So it's for the resume button. And then we're going to have the main menu button. Okay, let's save the script. And back in the editor, let's drag those references. So that's the main menu button and the resume button. Okay. So now for these, let's add the click action. So let's do a private void awake. And on awake, go into the resume button, the on click, and let's add a listener. So this is going to be our listener. And same thing for a main menu button. So main menu. Now for the main menu, this one is super simple. Let's just go into the loader and call the load function. And we're going to load the main menu scene. Okay, that's the main menu, very simple. And for the resume, this one is only going to be clickable when the game is paused. So we can just trigger the same function on the kitchen game manager to toggle the pause. So kitchen game manager, the instance, and toggle the pause game. This one is actually private, so let's go to it. And let's make this public so we can call it from there. Okay, that's it, super simple, let's test. Okay, so here we are, and let's pause the game. And now if I click on resume, yep, there you go, it does work, everything resumes. And now pause again, and now let's go back to the main menu, loading, and yep, there you go, back in the main menu. All right, awesome. So everything works perfectly. However, there's one sneaky issue here. You can already see the issue by seeing that all of these animations are still, but let's click on play. And nope, look at that issue, everything is still frozen. I cannot move the character, and over there, the shader, that one is completely frozen. So the timescale is still set to 0. Basically, we need to manually reset it. And the simplest way to do this is really just in the main menu. So we can go here on the main menu UI, and we can just use this as our reset function. So let's just go into time.timescale, and let's set this one back into 1F. That's it, that's the only change, let's test. So here we are, let's pause, let's go back into the main menu, and we can see the animations are indeed playing, and if we go back into play, and if there you go, everything works perfectly, we can pause. And yep, here we do see one of the other two sneaky issues left. Basically, it has to do with scene loading and cleanup. So the first one is on input. Over here on the game input class, we are constructing our player input actions, and we are listening to these events. And technically, this object, the one where the game input is attached, this object is going to be destroyed when the scene changes. However, this object that we're creating, this instance of player input actions, this one does not get destroyed automatically. So that is why when I went into the pause menu again for the second time, over here we've got a missing reference exception. Basically, the player input actions of the previous game is trying to show the pause window also of the previous game, which has since been destroyed. So obviously we have a missing reference exception because that object no longer exists. So in this case, we have two options to solve this. One option is we can just unsubscribe to these events. Unity mono behaviors have a really nice callback called onDestroy. So over here, private void onDestroy. So this is the default one. This one is called when the mono behavior is destroyed. So we can go into this one and we can manually unsubscribe. And the way that you unsubscribe is you just do -=. So this would solve that problem because when this object is destroyed, it's going to unsubscribe from those events. So the next time it will no longer trigger. So that would fix it. However, on the game input class, we are still creating a new object of this type. I'm not 100% sure how the input system works in the background, so perhaps this object might stay in memory, which is not good. So another approach we can do, or perhaps in combination with this, is we can unsubscribe and then we can properly dispose of this object. How we do that is very simple. Let's just go into the player input actions and we just call the dispose function. That's it. This should clean up that object and free up any memory. So let's test. So here in the game view, let's pause, let's go back into the main menu. Now let's go back into the main game. And now if I hit pause, and if there you go, we no longer have any errors. Okay, so that's good. However, now we still have one more potential issue, and this one has to do with statics. Like I mentioned before, statics belong to the class and not any instance of that class. So that means that static fields will not be destroyed or reset when the scene changes. In the case of our loader here, where we have a private static field, this one, the fact that this one doesn't reset automatically, that was a good thing. That's what allowed us to make the unloading system. But in the case of maybe static events, that might not be as good. It might mean that we might be keeping some state from the previous game, which might cause everything to break. So basically we have a similar problem to what we had in the input, where some logic from the previous game might be affecting the next game. In all the code that we wrote, the main place where we used statics were in the singletons. And these are going to be cleared automatically when the underlying instance object, when that one is destroyed, so these do not cause any problems. However, for example, over here on the cutting counter, we've got a static event. When the scene changes, this will not be cleared, so this will still have the same number of listeners. We can actually see how many listeners there are by printing it, so let's go down here before we're invoking the event. Let's do a debug.log, let's go inside the onAnyCut event, and over here we can get the invocation list. This one is a list of all of the functions that are listening to this event. And we can just print out the link to see how many listeners are listening to this event. So let's see what this returns. Okay, so over here, let's pick up some cheese and slice it. And if I look in the log, yep, there you go, 1. There's only 1 listener. Okay, that's correct. However, now if I go back into the main menu, and now I go back and I play again. Okay, so let's play. Let's just wait for the countdown. And once the countdown ends, pick up some cheese, go there, slice it, and there you go, there's the problem. Now we have 2 listeners. In this case, it doesn't really cause an error because the 2 listeners, They're just over here on the sound manager, so we are subscribing to this event and we're doing the cut and playing the cut object. However, if here we do something with this transform, like for example, let's just do a debug.log on this transform.position. If we do this, here, let's go ahead on the first one, let's slice, and okay, that works. Let's go back into the main menu. Now play again. Now wait for the timer. Pick up some cheese, go there, slice, and if there you go, there we have our error. That is because we are now accessing the sound manager transform, and that one has since been destroyed. So if you do use static events like this one here, if you do that, always remember you need to manually reset that state. It won't happen automatically on the scene load. And one way that I normally do it is just make a class responsible for doing that. So let's go ahead and let's create a brand new C# class. Let's call this the reset static data manager. And for this one, we want this one to run only on the main menu. That's only where we're going to reset things. So let's go inside the main menu scene. Let's go there. Let's create a brand new empty game object for the reset static data manager. Let's reset transform, just keep things clean. And let's attach that script. Again, it's very important that this object only exists on the main menu. Then over here, we're basically just going to go into any script and reset any data. So for that, on all those scripts, let's make a function. So over here on the cutting counter, let's make a public static function. Let's call this reset static data. And in order to reset any listeners, let's just go into the on any cut and set it to null. That won't clear all the listeners. So we just do this, and then on this script, let's do a private void awake. And on awake, let's go into the cutting counter under the class, so not any instance. So we're going to access the static, and we're going to reset the static data. That will clear all the listeners on the cutting counter. All we need to do is make sure to do this on every single static event that we have. So on the sound manager, and by the way, here we can get rid of the testing code. Here we can see all of the static events that we're using. So we've got the cutting counter, then we've got the base counter and trash counter. So let's go here on the base counter and paste the exact same thing and reset this event, okay? And now let's go into the trash counter. So here on trash counter, same thing, reset this event, set them all into null. And by the way, here we have a warning. That's because trash counter extends base counter. So basically this is telling us that we are hiding another function with the exact same name. In this case, we do want to hide it. So let's actually make this new to make sure that this one is a different one, just to avoid that warning. And same thing over here on the cutting counter, we also need to make a new. Okay, so that's it. And now we just need to go over here onto the reset static data manager. Let's go into the base counter and reset the static data. Go into the trash counter and reset the static data. Okay, that should do it. Let's see. So here we are in the game. Let's pick it up and slice it. And yep, we've got just one listener. That's good. Let's go back outside, back into the main menu. Let's play once more. And over here, let's pick it up again. Go there, drop it, and there you go, still just one listener, because we are now correctly eliminating all of the previous listeners. So this is the one sneaky issue that you must be careful with when it comes to object lifetime and statics. For static fields, you need to remember that they don't manually get cleaned up. That's up to you. So that's something you have to keep in mind, but you can also see how easy it is to solve. Now that this is solved, let's just go into the cutting counter and just get rid of our testing log. Alright, so with all of that, all of our scenes are working. So we can start from here from the main menu and go straight into the game. Then here we are in the game playing normally. We can pause the game at any point. From the pause screen, we can either resume or we can go back into the main menu. And from back into the main menu, we can once again play the game from scratch. And if there you go, everything works. Alright, awesome. Now the next thing that every game requires is some options, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to create a simple options menu where we can modify the audio levels. Okay, so here let's make the options menu. So on our game scene, let's go into the canvas and create a new empty game object. Let's make this the options UI. Let's stretch out this one to occupy the entire screen. Then inside, let's make a UI image. Once again, let's stretch out everything. Let's put this one in black in just almost full alpha. Okay. Now let's make some text. So let's create a brand new UI text. Call it the options text. Then for text, let's say just options. Let's put the width and height at 0. Let's disable wrapping, put it center down the middle, and put it quite a lot bigger. Okay, that's the options. Now just move it slightly upwards. All right. Now let's make some simple buttons to handle our audio controls. We're going to make it super simple, literally just a button we can click. So inside the options UI, let's create a brand new button. Call this the sound effects button. Then let's make the button a bit bigger, something like this. Okay. And inside for the text, let's say sound effects, and then we're going to have a number for the sound effects. Let's just quickly change the color. So put the text in white and the button over here, the button image, let's put it in a dark gray. Okay. Let's also make it just a tiny bit thinner, just like that. Okay. So this is the sound effects button. Now let's duplicate this one. This one is going to be the music button. So let's name this the music button. Then inside for the text, music, and then a number. And that's pretty much it. So by clicking on either of these buttons, we're going to increase and then loop the volume. So let's make a simple script to handle our options window. So in our scripts inside the UI, let's create a brand new C# script for the options UI. Let's go ahead and attach a script and open. So here, as usual, let's get some fields for our buttons. So a serialized field, private, of type button for the sound effects button. And then there's another one for the music button. Okay, both buttons. Now let's add the click event. So on private void awake, let's go into the sound effects button. And on the on click, let's add a listener. And we're going to do the same thing on the music button. Okay, so now when we click, we want to change the volume. So let's go here onto the sound manager and make a function to modify the volume. Let's make a private void change volume. And here we're going to increase the volume by 0.1%, so constantly increase in 10% increments. So that means we need to keep track of the volume. So up here, let's define a simple private float for the volume. Let's default it to 1F, okay. So now down here, we take the volume and we increase it by 0.1F. And now let's loop it back to 0. Now for looping, usually you do it using the modulo operator. So here you could do volume equals volume modulo of 1.1F. That way, when it gets to 1.1F, it would reset back to 0. But here, since we're working with floats, which can have a bit of odd precision, with this, let's just do a simple if to make sure that it always works. So if the volume is above 1F, if so, then let's just reset it to 0. Okay. So here we modified the volume, and let's just make sure to use it over here when we actually call the audio source.playClipAtPoint. Here we've got a volume, but this is the one that we received as a parameter. So let's actually receive this one, rename this to volume multiplier. And we're going to basically multiply the one that we receive in the parameter by the one that we actually store. So this way on these functions, when we play a certain sound, we can still give an optional volume if we want to make it louder or quieter than the regular sound effects. Okay, so we have our change volume function. Now we just need to call this from the options UI. So that means this one actually needs to be public. Okay. So now here on the options UI, we go into the sound manager, access the instance and call change volume. Okay, so that is going to change the volume. Then we just need to update the values on the options UI. So let's make a private void update visual. And this one we need to update the text. So up here, let's add once again some more serialized fields. So text mesh pro UGUI, one for the sound effects text and another one for the music text. Okay, we have both these. Then here the sound effects text.text equals, and we go into the sound manager, the instance. And then we need to get the volume. So over here on the sound manager, let's make a function to get it. So a public float return get volume, and we just return the volume. Okay. So then here, let's get volume, except the volume is going to be a normalized value. So rather than showing 0.1, 0.2, 0.3 on the UI, let's just multiply the volume by 10F. That way we show between 1 and 10. Okay, then let's just round out this number and then add the text. So here's sound effects, and then we have the volume. Okay, so that's pretty much it. And up here, when we change the volume, let's just update the visual. And let's also make a private void start. And on start, let's also update the visual. Okay, that's it. Pretty simple. Now let's do the exact same thing on the music. Except on the music manager, we named it music manager, but over here we just have an audio source. There's no actual manager. So let's actually make one. Let's create a new C# script for the music manager. Let's go into the music manager object. Let's attach a script and let's open. So here we really just need pretty much exactly the same thing that we had. So let's just go here into the sound manager and just copy these. So on the music manager, let's paste them. We need a volume, so a private float for the volume, just like this. Okay, so that changes the volume. Except again, the music manager, this one, the music is constantly going to be on looping. So after we modify the volume, we need to update the actual audio source. So let's first begin by grabbing the audio source, and we just do a private void awake. And on awake, let's grab the audio source, get the component of type audio source. Okay, so we have this. And when we change the volume, let's go here and update this volume. Okay, that's it. And let's also default it to something like 0.3F. Okay, good. Then in order to be able to call this from the options UI, we just need to make it a singleton. So as usual, public static music manager for the instance. And we have a public get and a private set. And then an awake, just set instance equals this. Okay. So then here on the options UI, we can go into the music manager, the instance, and change the volume. And afterwards, let's update the visual. And down here on the update visual, let's do pretty much the same thing. So on the music text, modify the text to say music. Then we go into the music manager and get the volume. All right, that's it. All this should be working. Let's just drag our references. So back in the editor, let's drag first the button. So the sound effects button, that's this one. Then the music button, that's this one. Then we have the music text, that's this one. And the sound effects test like that. Okay, let's test. Okay, so here we are, the music is playing, and as I click, the music is currently getting louder and louder. And there you go, music is at max volume, and if I click again, now the music is completely muted. Alright, awesome, and these sound effects also work, so like this, they should be less louder than usual. Okay, great. So everything works perfectly, except obviously we have one big issue. The options window is on top of everything. The goal is for the options window to be kind of a submenu of the pause window. We want to have an options button on the pause window that will bring up the options window. So let's do that. Let's first hide the options window. Let's go into the game pause UI. And over here we have these buttons. Let's just make one more. Let's put it down the middle. This is going to be the options button. And inside, let's modify the text to options. Okay. Now let's edit this script. So we're going to have another button. So this is the options button. And down here, we're going to have another click. So the options button. Okay. And when this happens, we want to just show the options window. So in order to access it, let's make this a singleton. So public static for the options UI, a static instance with a get and a private set. And on awake, as usual, instance equals this. So over here on the game pause UI, we go into the options UI, access the instance, and then call a show function. So we need to make this. So up here on the options UI, let's make those. So a public void show. And this one, as usual, just game object set active into true. And then we have a private void hide. And this set active into false. Okay, we have both these. On the other side, we show it. And over here on start, let's also hide it. Okay. Then let's also hide it manually. So let's add a button to close the options UI. So over here, let's show the options UI and let's make another button. Let's put it on the bottom. This one is the close button. And over here, let's just say close. So then here on the options UI, just make another button, the close button. And down here for the click event, we go into the close button and we just call hide. Okay, so that won't hide the window. However, remember that the pause window can also be closed by just pressing escape. If we resume with a hotkey, it will hide the pause window. So let's also make sure this one hides on the same thing. So we can do pretty much go into the kitchen game manager, the instance, and let's listen when the game is unpaused. So when that happens, let's hide this window. So once again, let's do things nice and clean. Let's rename this. So the kitchen game manager. And when this happens, let's just hide. Okay, this should work. Let's just drag all the references. So first here on the options UI, let's drag the close button. And then on the game pause UI, let's drag the options button. Okay, so let's test. And yep, right away the options window is not showing. That's great. And if I press an escape, there you go, there's the pause window. And if I click on options, yep, there's the options window. Now if I click on close, back here, back into resume, okay, works. Now if I pause, options, and now press on the escape key, and yep, there you go, it closes everything. All right, great. So everything is working fine. However, we have one slight issue. The option does work, so I can modify this to change the sound effects and the music volume. So for example, let's mute the music and put the sound effects on 5. So I put it like this, but now if I stop playing and I hit play again and look in the options, and nope, there's the issue. Basically the data is back to the default. Obviously that is resetting since we didn't actually save anything, so let's save it. Now in Unity, the easiest way to save some data is using player prefs. So let's go over here on the sound manager, and when we modify the volume over here, when we do that, let's access the Unity player prefs, and over here we've got a bunch of set functions. So we can save a float, an int, or a string. This one, as you can see, takes a string and a value. So this is pretty much essentially just a dictionary. Now for the key, as you can see, it's a type string, but again, we should not be using strings directly. So let's go up here in order to make a proper constant. So a private const string, let's call it player prefs sound effects volume. And let's go sound effects volume. Okay, we have our nice certain constant, and down here, when we set the float, let's use this string and save the volume. Okay, so that is going to set the float. And now technically Unity is going to automatically save the player prefs. Basically there are only problems if Unity somehow crashes in between when you call set float and when it actually saves. But if you want to prevent that from happening, you can just go and tell it to save manually, just like that. That will definitely save it. And now we just need to handle loading. So up here on awake, when we have this, let's go into the player prefs and let's use get float. Let's pass in the same key. So this one takes a key and default value, so let's default it to 1f. Basically the default value is used if there's no saved data on this player prefs on this key. So the first time we run, it's actually going to use this default. And this one's going to return the saved value, so let's just set it on the volume. Okay, so that's it. That's all it takes to save some basic data. Now let's do the exact same thing on music. So over here on the music manager, let's first define our private const string for the player prefs music volume. And this is going to be the music volume. Okay, we have our string. And then down here, when you change the volume, player prefs. And let's set the float on this key, and let's pass in the music volume, okay? And then let's go into player prefs and actually save it. And now up here on awake, let's grab the volume, and it's going to be going to the player prefs in order to get the float on this key, and default value is 0.3f. However, over here on the music, again, we are not spawning the sound afterwards. The sound starts playing right away. So let's make sure to set the audio source volume to the one we grabbed from there. Okay, that's it. So like this, it should be working. So let's test. So here we are and the music is playing. Let's pause, go into the options. Let's bring the music completely down. So let's mute the music. Okay, the music is gone. And sound effects, let's put it on 5. Now let's stop playing and now play again. And go into the menu, options, and yep, there you go. The data was indeed saved and the music is indeed muted. All right, awesome. So here we have some basic data being saved. And also just a quick note related to saving. For this simple game, the sessions are pretty quick, so I didn't include any kind of save system for the actual game data. But if you want to know how to do that, I also have video covering that topic. Okay, so with that we have our options window working. The volume sliders work perfectly. The next thing we need to add to our options is some key rebinding. So let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to add key rebinding to our options menu. So here we already have this nice options menu. We can modify the volume of the sound effects or the music. Next, let's handle key rebinding. Okay, so first let's build the elements over here on the UI. So let's create a bunch more buttons. But before that, let's actually make some text on the side and buttons in the middle. So let's create a brand new UI text. Call this move up text. Let's put it on the same size as the other one. So these got a font of 24. So let's put it the same thing, font of 24. Width and height, let's put both of these on 0. And down here, anchor it to the left, okay, down the middle and with no wrapping. Okay, so then over here, this is going to be the move up action. So we have move up, then we have the move down, move left, move right. Then we have the interact alternate, and finally the pause. So these are all of our actions. So let's just make all of these. So rename this. So this one is the move down. Then this one over here is the move left. This one is the move right. This one is the interact text, then the interact alternate text, and finally the pause text. Now let's just modify the text on these. So that's the pause. That one is the interact alt. Then this one is the interact. Then we've got the move right. Then over here, the move left. And finally, we have the move down. Okay, so those are our labels for our controls. Now let's just make buttons over here on the right side. So let's duplicate one of these buttons. Let's put it over here and put it on something like 50 by 50. So this is going to be the move up button. And inside on the text, this is going to be pretty much just a W, okay? So we have the move up. Then we're going to have the move down, move left, move right, the interact alternate, and the pause. So we just need a bit more space, so let's move all of these up by quite a bit. Let's also move the music and the sound effects. So move all of these like that. Okay, let's just name all these buttons. So this one is the second one, so this is the move down. Then over here, the move left. Then the move right. Then the interact button, the interact alternate button, and finally the pause button. Okay, those are all the buttons. Let's just position all of the labels exactly where they should be. Okay, so here we have all of the options, all of our bindings. Now in code, let's grab references to all the buttons and all the text inside the buttons. So over here inside the options UI, let's add all of those. So first of all, for the text, we're going to have the move up text, then the down, left, right, and so on. So let's just do all of these. So down, then over here the left, then the right, then the interact text, the interact alternate text, and finally we have the pause text. And for the buttons, let's go up here, make all the buttons. So the move up button, then the move down button, then we have the move left button, then the move right button, then we have the interact button, the interact alternate button, and finally the pause button. Okay, so we have all of these references. Over here in the editor, let's just drag them. So let's make sure we drag them all correctly. So let's do it one by one. So the move up, this is the text. And actually it's not that one, so that's already a mistake right there. We want the text from inside the buttons. So let's pick up all of these text objects. So let's go into the options. So text inside the move up, let's grab that one. Then inside the move down, let's grab that one. And the left and so on. So definitely make sure you grab the right ones. Okay, that's all text. Now for the buttons, so that's the move up button, then the move down, then the move left, the move right, the interact alternate, and finally the pause button. Okay, great. And just to verify that everything is working, let's give proper names to these objects. So the move up button text. Okay, so I've renamed all the buttons. So now over here, it's much easier to verify that we have the correct references. So the sound, music, and so on. So definitely make sure all of these are correct. Otherwise, you might go crazy when things start to go a bit weird. So make sure these are all correct, all right? Now let's begin by updating the text inside over here. So let's go into our update visual. So we go into this, set the text, and now we need to get the binding text for this binding. So for that, let's make that function on the game input. Over here, let's just comment this out. Then over here on the game input script, let's make a function to get the bindings. So technically we could make something just to grab this player input actions, but again, we don't want the options UI to know what input system we're using. It should work regardless of what input system. So we don't want the game input to return anything of this type. Instead, we want to make a nice layer of abstraction. So for that, let's make an enum to define all of our bindings. So let's make a public, since we're going to access it, enum, call it binding. And over here, let's add all the bindings. So we've got the move up, then we have the move down, the move left, the move right, then we have the interact alternate, and finally the pause. So these are all of the bindings. Now let's make a function to return the binding text. So over here, let's make a public. We're going to return a string. Let's just name it get binding text. And as a parameter, let's receive a binding. Okay, so now here, let's just do a switch on this binding. and basically just match up the enum to whatever action we have. So for example, let's begin with the interact, since these are the simplest ones. So for this one, to get the bindings, we first go inside the player input actions, then let's go inside the player action map, then for the action, so in this case the interact, and then inside we've got the bindings. This is an array of all of the bindings. In our input map, we defined all of the keyboard bindings on index 0. Later on, we're going to add gamepad bindings, but for now we're going to have the keyboard always on index 0. So over here, going to bindings, access on 0, and let's just do a toString. Okay, so let's just return this, and let's do a default to return always this one, just like this. Okay, so let's do a quick log to see what this returns. So let's do it over here on the game input, just a debug.log, go into there, get the binding text for the interact. Okay, so let's test. And right away, yep, we do see it working. So the interact and the binding is on keyboard/E. But we don't want all of this text, we really just want to see the E. Thankfully, the input system has a really great function for just that. So instead of calling the general toString, let's call toDisplayString. Let's see. And yep, this one does return just the E key. Okay, great. So this is the one that we want. Let's do the same thing for all of the other simple actions. So we've got the interact, then we have the interact alternate, and we have the pause. So these are all the super simple ones. So just going to interact alternate, grab the binding on 0, and for the pause, binding on 0. Okay, so these are all super simple. Now the more complex one is the move. It's more complex because you can see all of the others just have one binding, except for the move over here we have a composite binding. So that's basically a binding which inside has 4 separate bindings. Basically the way that this works is that when you use a composite binding, all of these are added to the array. So this 2D vector is going to be on binding 0, then the up is going to be on binding 1, 2, 3, 4, and so on. Then the arrow keys, this one is going to be on 5. Then we have 6, 7, 8, 9, and 10. Let's do a log just to verify. So here, if we do one for the move up action, for this one, let's go into the move, and let's print out just the binding 0. Let's do a regular toString. Let's see what this returns. So up here, let's just modify our log to say the move up. Okay, so let's see. And yep, index 0 does have the move to the vector. And now if we print the one on binding of 1, yep, now this one does have the move on the W. So like I said, we can see that all of these composites, these are technically inside that one, but in terms of that array, it's just a flat array. So this one index 0, 1, 2, 3, and 4. So that makes it super simple to add over here. So the move up, down, left, right. And let's just do all these. So we have all the bindings, and over here just 1, 2, 3, and 4. And instead of toString, let's call the display string. Okay, so the binding text, this is all set up. So let's go up here and get rid of our testing code. We can now call this from the options UI. So over here, let's do exactly that. So when we update the visual, let's go into the game input. Let's access the static instance. Let's get the binding text. And this one is going to be the move up. So that's it. This one is going to return a string. Let's write all of them. Okay, here are all of them. So let's see. And yep, there they are, all perfect. WSAD, EF, escape. Okay, great. So the visual is working. Now let's handle the rebinding. So let's add a click event. Let's go into the move up button. Let's go into the on click. Let's add a listener. And for the listener, over here, let's make a function on the game input to rebind this binding. So over here on the game input, let's do a public void rebind binding, and we receive a binding. Now for rebinding, I covered this in detail in the dedicated input system video. First, basically, we need to disable the action map. So let's go into the player input actions. Let's access the player and disable it. So we need to do this first. Then we're going to need to find the action. So player input actions. And for now, let's go into the player and let's just modify the move up action. So we're going to call the function perform interactive rebinding. This one, as you can see, takes a binding index. And if you remember up here, we saw that in order to modify the move up, it's on bindings index 1. So let's modify the one on index 1. Okay, so this is the function. This returns an object of this type, a rebinding operation. This is a pretty complex object where you can modify all kinds of things, add a bunch of limitations and so on. Like for example, make a key not be able to be bound to the mouse or something. So there's tons and tons of options you can play with. Over here for the simple thing, let's just add an onComplete listener. So this one takes in a callback, and this will be called whenever the interactive rebinding completes. So over here, let's define a lambda, so a callback, and inside we have this. By the way, over here, this is the same lambda expression that we saw previously. So exactly the same thing as this, except when we have just one parentheses, we don't need to add them. Okay, so like this. So then on this callback, we can see all kinds of things. Like for example, we can see the action that we just rebound. This is going to contain all the data on the rebind operation. So for example, let's print out the path. So let's go into the action. Let's go into the bindings on index 1, and let's print out the path. So let's do a debug.log. And there's actually another one. So let's log the path and also the override path. These are two different things. Let's see why in a bit. We do this, and after we log, we also need to re-enable the player action map. So let's go into the player input actions, the player, and back enable this. Okay, so we're only going to need these settings on the rebind action. Then we can just call start in order to start the rebinding process. Okay, so this should work. Let's just call this from the options UI. So over here we have the click. Let's go into game input, instance, and let's rebind the binding. And for this one is the move up. Okay, with this, let's test. Okay, so here if I click on the button and now I click on the T key, and if there you go, it did work. So you can see that it print out the regular path, that is W, and the override path, which is T. So now if I exit out of the options, go back into the game, if I press W, nope, it does not move, but if I press T, yep, it does move upwards. Okay, great. So we have successfully rebound this one key. Now here, just one thing. In previous versions of the input system, when doing a rebind operation, you needed to manually dispose of this callback, otherwise it would throw a memory error. In the recent version that I'm using here, there's no error, so it seems perhaps it's no longer needed to dispose of the callback manually, but still there's no harm doing it just in case. Over here, callback.dispose. Okay, so with that the key rebinding is working, except we have two issues. The first one is that it's not very clear that it's listening for an input, and the second one is that the text options also does not update. So let's solve both those. First, let's add a visual when waiting for a key press. So inside the game options UI, let's create an empty game object. Call this the press to rebind key. Let's stretch it out, so put it on 0 on everything. Okay. Then inside, let's add a UI image. Let's put it in black, and once again, let's stretch it out. Okay, now let's also add a simple text. And for text, let's say press a key to rebind. As usual, let's put the width and height on 0, put it in bold, center down the middle with no wrapping, and increase the size by quite a bit. Okay, so that's our super basic window. Now in the code, we just want to show and hide this, so let's do that. And let's actually begin with this hidden by default, so let's disable this object. So here on the options UI, let's add another serialized field. It's going to be a transform for the press to rebind key transform. So you have this, let's make two show and hide functions. So we show press to rebind key. We just go into that one, game object set active, this one into true, and another one where we set it to false. So just hide and set it to false. Okay, pretty simple. Let's make sure to hide this over here on our start. Okay, just like that. And for showing, let's show it when we actually rebind an action, so right in here. But since we're going to have tons of listeners to these events, let's actually make a nice separate function to handle all of the rebinding logic. So down here, let's make a function, rebind binding. We receive a game input.binding. And then first we show the press to rebind key. And then let's go into game input, access the instance, and tell it to rebind the binding and pass in the same binding. Okay, so we have this, and now up here on the button event, let's just call in this function. Okay, very simple. So this will work for actually showing the window, but now we need to know when to hide it. And for that, let's use something that we've used a few times in this course, but never directly. Let's use a C# delegate. As usual, I have a dedicated video on them. This is basically how you can define a field or a parameter of a type which can hold a function. It's another super useful C# feature. Definitely watch that video to learn all about it. Let's go here on the game input, and down here when we have our rebind binding, Over here, let's receive a second parameter. This one is going to be of type action. This is one of the built-in delegates. It takes no parameters and returns void. So this one is perfect for a simple callback just like this one. Let's call it on action rebound. And we're going to trigger this right here after we achieve the callback. So we get the callback. Let's trigger this just like that. And let's also get rid of these testing logs. We no longer need them. So just like this. Now back here on the options UI. So we've got that. And for the second parameter, let's just pass in the function to hide that window. So hide the press the rebind key. That's it. Again, remember, we're passing in the function itself. We're not calling it. So there's no parentheses. We're just passing in the function itself. Okay, so with this, let's test. So here on the options, let's rebind the move W, and there you go, it does show up the window. And now if I press a key, yep, there you go, that one hides. Okay, great. So this is working, but over here the text is still not updating. So over here on the second callback, instead of just calling this function, we need to call this and then also call the update visual function. So as usual, let's use a simple lambda expression to do exactly both. So let's open and close the parentheses, and we do exactly this. So we hide the press the rebind, and then we update the visual. Okay, that's it, let's test. So here we are, let's rebind the move W, press on the T key, and there you go, it did rebind and it did update. All right, great. Now let's just apply this to all of the other bindings. So first up here on the buttons, let's set listeners to all the buttons. So that's the move left, actually the move down, then the move left, move right, the interact button, the interact alternate button, and finally the pause button. And for the bindings, this one is the pause binding, the interact alternate, then the interact, then the move, this one is the right. Again, make sure you don't make mistakes here, you call them the exact same one. So the move down, okay, so all of it is correct here. And over here on the player input, let's do a switch on our binding. So K's move up, we do something. And now we could write this code directly up here and then make a move down and write a bunch more code. That would work, but that would be way too wordy. So let's write our code in a nice clean way. Basically, the only thing we need down here is we need to know the actual action we're going to rebind, and we need to know the action index. So let's just find up here exactly that. So an input action for the input action, and then an int for the binding index. Okay, and then over here, when we have the switch for all of our bindings, we just set those. So the input action, in this case, it's going to be the player input actions, player, and it's the move action. And for the binding index, this one is on index 1. Then we're going to have the other moves. So the move down is going to be on index 2. Then left and right. These are on index 3 and 4. Okay, so we have all these, and now for the other ones. So for the interact, this is the interact action on binding 0. Then we've got the interact alternate and the pause. So interact alternate and the pause. And this one is the pause action and the interact alternate action, and all of them are on binding index of 0. Okay, so that's good. So over here we are assigning the input action and the binding index. And also one thing, we need to make sure to always assign these values. So let's make sure to add a default here, just make sure it always works. Okay, great. So now down here, instead of always accessing the move, let's access whatever is stored in the input action. And for the binding, whatever it is on the binding index. Okay, so now this will work with all of our bindings. So here we are, and let's try rebinding all of them. So let's put them over here on the side. So for the move up, let's put it on T, down on G, A on F, then D on H. For the interact on Y, interact alt on J, and for the escape, let's put it on E. Okay, so all these keys have been rebound. Let's just make sure they work. So here I am moving with these keys, and yep, it does work. Go up here to interact, and do the alt interact, and now the pause, and yep, there you go, everything works perfectly. All right, awesome. So everything worked perfectly, although again, we have the same issue as previously. So all the keys have been rebound, so it's all correct, great. However, now if I stop playing, and now if I play again, and nope, there's the issue, the rebinding was lost. So just like with the sound, we also need to save the new state. Now, thankfully, the new input system has a function that makes that super easy. Let's go down to where we are rebinding things. And when we finish rebinding, let's just go into the player input actions. And let's call this function the save bindings overrides as JSON. This one is going to return a JSON string. Now, if you don't know what is JSON, go watch my quick video on it. Basically, it's a super easy to understand and widely used file format. It's very easy to read and modify. It's a format where it's stored as just text. So let's look at what this says. Let's do a debug.log over here after rebinding something. Let's see. So here, if I rebind one of these, and if there you go, there we have our JSON. So the override bindings that overrode the move on this ID on this new path. So basically, we just need to store this string somewhere, and just like we did with the sound, let's just store it in the player prefs. So first, let's define our constant. So private const string for the player prefs bindings. And let's call this the input bindings. Okay, just like this. So then down here, after we rebind the key, let's go into player prefs and let's set a string on the player prefs bindings. And we're going to save the overrides as JSON. And after we do, let's just make sure the player prefs is correctly saved. Okay, so that saves it. Then let's go on awake to load it. So over here on awake, let's load that. Let's first do a quick test to see if there's a save. So if the player prefs, if it has a key, and if it has this key, if so, then let's get it. So the player prefs, let's get the string on this key. That returns the string, and we're going to use the string. Let's just go into the player input actions. And let's call the function load binding overrides from JSON just like this. And also let's make sure we do this right after we construct the object and before we enable the action map. Okay, so that's really it. Let's test. So here we are. Let's rebind the move up to T. Okay, it rebound. Now stop playing. Now play again. And yep, here it is, still rebound to T. All right, awesome. Okay, so here we created a really nice options menu where we can modify the volume and rebind keys. The only issue that we still have is that we can only navigate the menus with the mouse, so let's add support for menu navigation with a controller in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to set up full controller support for our game, including regular actions and menu navigation. Okay, so first let's just set up the controller inputs. I have an Xbox gamepad controller connected, so let's open up our player input actions. And over here we have all of our actions, and we already made the move one a long time ago. So let's just add the bindings for the other ones. For example, over here on the interact, let's add a brand new binding. Let's go into the path and listen. And for interact, I'm going to press the A button. And again, here you can specify just the A button on an Xbox controller, or you can use the generic South button, which will mean A on an Xbox, or cross on a PlayStation, or B on a Switch, or anything else. So let's go with the generic one. For the internet alternate, let's add a binding, and for this one I'm going to put it on the X on the Xbox, so the button west. And for the pause, let's add, let's listen, and I'm going to press the menu, which is the start button. Okay, so these are the basic inputs. Let's make sure they work, and thanks to this new input system, we really don't need to modify any code. Let's just save this asset. Let's wait for the compilation, and then we can do a test. So here we are, and yep, I'm using my controller to move. Now let's just wait for the countdown. And go up there and pick up a cheese, put it and slice some cheese. Yep, I can do that, pick up a plate and so on. All right, so everything works. Let's also pause, and yep, that also works. Okay, great. So everything works, except there are two issues with the gamepad, especially one with the movement that I only noticed just now. The first issue that we have is the dead zone. Right now we don't have one. So if I just lightly touch my gamepad joystick, there you go, it starts moving automatically. In gamepad games, you should always have some kind of dead zone to prevent any kind of Joy-Con drift. Thankfully, that is super easy to solve. Let's just go into the player input actions, let's go into the move, find the left stick binding, and over here for the processors, let's add one, and let's add a stick dead zone. So that's it, pretty simple. This basically considers that inputs under this minimum to be 0, and above this maximum to be 1. So if you have joystick drift, where when the joystick is idle, it's always moving by, say, 0.1 in direction, this helps solve that problem. Except in our case for our game, we're only using normalized inputs. So actually, for our use case, let's increase the minimum by quite a bit. I did some testing and 0.5 works quite great, and the max at default, that is just fine. Okay, so that's it, one problem solved. Let's just go ahead, save this asset. Now the other bigger issue that we have is if I approach a counter and I try to look at it, it's really difficult. It tries moving left and right instead of actually facing the counter. That's because of the logic that we added a long time ago, that logic to help the character controller feel better when moving on diagonals against a counter. That works great for keyboard because it's digital, so it's either moving fully left, fully right, or on the diagonals. But it messes up the controller, which is analog. On the player movement, if we are not moving perfectly up or perfectly down, then it's considered a diagonal. And on the gamepad, it's really difficult to get a perfect just up or just down input. We're always going to have a tiny bit of either left or right. So that's the issue that we have here. And thankfully, the solution is actually pretty simple. Let's go over here onto our player script, and let's scroll down into the handle movement function, okay? So we're doing a can move using the regular move direction, and if it doesn't work, then it's over here that we are attempting only the X movement or only the Z movement. And for doing that, we made it so we can move if there's nothing only on the X, and if we have any movement at all on the X. So if it is different from 0. Basically, the issue here is if the moveDir.x is, let's say, 0.001, that is still different from 0, so it is still going to trigger this logic. So basically, let's just widen this gap. Instead of testing literally just different from 0, let's test if the moveDir.x, if it is under, say, minus 0.5f, or if moveDir.x, if it is bigger than plus 0.5f. So instead of being exactly just on 0, we're only going to consider diagonals if we are at least moving 0.5 either left or right. So we just do this, and same thing over here, except we just test for the z, so the moveDir.z and the moveDir.z. Okay, so like this, it should feel much better on the gamepad and still work exactly the same on the keyboard. So let's test. So here I am moving around, and yep, now it is much easier to just stay around and look straight at a counter. Okay, so that's great. So I can pick up, and this is all much easier, and the character is no longer just sliding left and right nonstop. Okay, that's great. So now that this is working, let's add support for rebinding our controller bindings. So over here on the game input, let's do it just like we did for the keyboard. So let's add a bunch more bindings over here on the enum. Let's add the gamepad interact, then the gamepad interact alternate, and then the gamepad pause. Okay, so we have our bindings. Then let's go down and add them to both our functions. So first the text and then the bindings. So over here on the text, let's copy pretty much this. We're going to have the gamepad interact. Then we're going to have the other two. So the gamepad interact alternate and the gamepad pause. Okay. Now for these bindings, we're going to use the same actions. So this one is the interact alternate, and over here we have the interact. And over here on the input actions, we saw that we added for all of them. On index 0, we have the keyboard, and on index 1, we have all of the gamepads. So over here, that's literally the only change. For the gamepad, let's go into bindings and access the array on index 1. Okay, and then over here on the rebind binding, it's going to be pretty much the exact same thing. So let's copy all of these, change this to the gamepad interact, then the gamepad interact alternate, and then the gamepad pause. So on all of these, all we need to change is just the binding index, put them all on 1. Okay, so with that, all of the code over here on the game input is working perfectly. Now let's go over here into our options UI. So we've got all of our buttons. So let's duplicate our buttons. Let's just go into the interact, the pause, and so on. Let's duplicate, push them to the right side, okay. And just change the name. So let's go into all of them. So this one's the gamepad interact button, then the gamepad interact alternate, and finally the gamepad pause, okay. Also inside, let's also rename these buttons just to make sure the text works great. And let's also make sure that these show up behind the press the rebind key. So let's drag them, put them above. Okay, so that's our setup over here on the options UI. Now let's go over here on the options UI script, and let's add references to our buttons and to our text objects. So let's copy all of these, the gamepad, and add all of these. This is the pause, the interact, and the interact alternate. And then down here, the exact same thing. Let's add all of these. Okay, like this. Now over here, let's drag all of our references. So on the options UI, let's make sure to always drag the correct things. So the gamepad interact text, the interact alternate text, and the pause button text, and then the buttons themselves. So the pause button, interact alt, and the interact button. Again, make sure you always drag the correct references. So check and double check, make sure everything is correct. Okay. Then over here for our code, let's first handle the text over here. So the text for all of these, so the gamepad interact text, then the gamepad interact alternate text, and finally the gamepad pause text. And we just go the gamepad pause, the gamepad interact alternate, and the gamepad interact. Finally, over here on the buttons, let's do the exact same thing. So gamepad interact, interact alternate, and the pause. Okay, so we added everything. Let's do a test and see if everything is working. So over here, let's pause the game, go into the options, and for the interact, let's modify this one. Instead of A, let's put it on B. And yep, there you go, it did go. So let's close, let's resume, and now let's see. So if I approach and I press A, nothing happens, press B, and there you go, it does interact. Okay, awesome. So the rebinding is all working perfectly, except we have another obvious issue. I can pause with the gamepad. However, now with this paused, I cannot click on any of those buttons. And if I go back to the main menu, over here I also cannot do anything with the controller. So let's solve that. The first step is on the event system object. Look at how it shows us this warning. Basically, if we're using the new input system, we should be using a different input handler here. Thankfully, this is super easy. We just need to click on this button, and yep, that's it. It automatically sets it up. Now, the way that this works is by pre-selecting buttons. And in order to better see which button is selected, we should probably add a more visible color. Let's go into our pause window. So for now, let's hide over here the options UI, show the pause window, and we have these three buttons. Let's select all of them. And over here on the right side, on the button, we can see one option for the selected color. So instead of being white, which is going to be really difficult to see, let's put something really visible. So let's say like a bright green. Okay, like this. Let's do the same thing for all of the buttons on the options UI. So let's show this one and find all of the buttons. So we've got all of these ones down here and these three ones up here. And let's do the same thing. So on the selected, let's put it all on a nice green. Okay, so all the buttons have a nice selected color. And just like this, if we test, and if I pause the game, and right now nothing is selected. So right now I cannot do anything with the controller. However, if I press over here with the mouse on this button and then let go whilst outside the button, yep, look at that, now that button is selected. So now as long as that one is selected, now if I move with the mousepad, yep, now I can navigate through this menu. And if I press on A, yep, I can essentially click that button. So that's great. Basically, all we need is to make sure that we select the button as soon as the pause menu shows up. So let's go over here on the game pause UI script. And then over here, let's go into the show function. So when we show this window, when we do, let's go into the resume button and just call the select function. This will make it selected. So that's it. And with this, if we test, and now here with the game playing, if I pause whilst pressing the button on the gamepad, and if there you go, that one is selected, and now I can select any option. Okay, that's great. So now it works fully with just the gamepad, except now if I go into options, yep, now you can see that the button that is selected is still in the options one over there on the background. So let's also make sure to select the button on the options as soon as the options window shows up. So over here on the options UI, let's go into our show function and let's just select the sound effects button and just call select. Okay, let's test. So here, let's pause, go into options, select, and yep, there you go, that did work. Okay, great. Except we have another issue. As I move up or down over here on these buttons, yep, look at that, some of them are a bit strange. Like for example, over here on A, I'm moving up, and look at that, it actually selected the resume button behind it. So as we are moving up and down, we are actually selecting buttons on both menus. That's very strange. Basically what is going on is that since both windows are visible, the game is trying to guess which button we want to select. Basically what is happening is Unity is trying to use automatic navigation. If we select a button, so let's go, for example, let's hide the options and show just the game pause. Okay, let's select one of these buttons. And over there on the button component, we can see navigation is set to automatic, and we have a button to visualize. And if we click on that, yep, over here we can see all kinds of arrows. For example, we can see one over here on the options that seems to be going to some button in there. That is going to be the button that is showing over there. So if we move down from the options, we're going to end up over here on the interact alt button. Now usually, the automatic navigation actually works very well. The only reason why we're having problems is because we have both windows active at once. One solution to this is to make the navigation explicit. So let's hide the options here, and over here on the resume, on the navigation instead of automatic, let's put none and then let's select explicit. And yep, now we have all four fields. So we can decide which object gets selected when we are here and we move up, down, left, or right. So for example, here we would drag for the up. Going up, we could go into the main menu, so we would drag that button, and going down, we could drag the options button. So that's one solution, just add the explicit navigation to every single button. Or another simpler solution is let's leave this one on automatic, and instead we're just going to hide the pause window once we are in the options window. So over here on the game pause UI, let's see over here we are showing the options UI, and when we do, let's just call hide on this. So we are going to hide this window when we show the options. And then on the options, we want to know when the options closes so that we can show this one again. So over here on the show function, let's receive an action. This is what we're going to do when we close the options. Let's call it on close button action. And let's store it up here. So let's store a simple private action for this. Okay, so we have this. And then down here when we have our show function, when we have, let's set this equals this, we store this. And then we're just going to run this action whenever we click on the close button. So let's go over here, the close button, we've got that one. Let's hide the options window and trigger this action. So now all we need is over here on the game pause UI, let's pass in, and basically when we close the options UI, we want to show the pause UI. Okay, so let's test. So here we are, let's pause the game. Okay, let's go into options and open it. And if there you go, it only shows the options. And over here, moving up or down works perfectly, and moving left and right also works perfectly. And now if I want to go back, let's go into close, press it, and there you go, back into the pause menu. All right, awesome. So everything is working perfectly. Now the last thing we need is over here on the main menu. So let's do the same thing. First, let's open up the main menu scene. Let's save the changes, okay? And over here, let's begin by doing the same thing on the event system. So let's replace it. Okay, great. Then let's go inside our canvas, inside the main menu UI. Let's select our buttons. And once again, let's modify the select color, put it on nice green. All right. And since over here, we only have one menu, we could set it as selected over here on the main menu UI script. That's one option. Or we can just go into the event system. And over here on the event system, there's a field for the first selected. So we can just drag the play button and that will automatically make it the selected one. So let's test. And yep, the play button starts off as selected and I can move up or down. And if I press a button, yep, there you go. Here I am playing the game. I can pause, I can resume, go back to the main menu and so on. All right, awesome. So here we had the final thing we needed to make our game fully playable with the gamepad. Thanks to how the input system works and the menu automatic navigation, this was a pretty simple task. With this, our game is pretty much completely done. However, the next lecture is also one of the most important lectures. It's all about polish, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to add all kinds of small things to polish up our game. If you're a regular on this channel, then you've certainly heard me say that polish is what separates good games from great games. So as you build your own games, make sure you don't neglect polish. Here, let's add a bunch of small, tiny things that will make a big difference in the final game. Let's begin with a very simple, very visual one. Let's just add some walls to our map. And first, let's just hide our canvas so that it's not blocking our view. So again, over here, we can use the buttons on the hierarchy to hide it. Okay, great. So let's add some walls. And for that, let's create a brand new 3D cube. Let's name this a wall. Let's put it quite a bit thin. So over here on the scale, for the X, let's put it 0.25. Then on the Y, let's put 3. So something like this. Then we modify the Z. So let's put it over here on the side, right next to the counters. Okay, so that's the wall. Let's just stretch it out one direction and the other one. Okay, so that's our basic wall. Now in the included project files, there's a nice wall material. So let's go over here into assets, under materials. And yep, here it is, the wall material. So let's just drag it and use this one. And yep, there you go. It's just a nice simple gradient. This is also an example of how you can take something simple and make it a bit more interesting. If you look at this material, the base texture is really just this. It is literally just a simple vertical gradient texture. And then with a color applied to it, and it looks pretty good. Okay, so this wall, let's put the wall on all three sides. So let's duplicate this. So just select and press Ctrl D, duplicate. Let's put one on the other side. So right there, right next to the counters, okay. And finally the one there, so Ctrl D to duplicate it. Let's push it over there on the side and rotate it 90 degrees. And let's put it just like that. Let's just scale it to get to that end and to get to that end. Okay, so we have our nice walls. But over here, if we're playing the game, we can still see the floor on the outside. That looks a bit ugly, so let's fix that. Let's create another object, and let's create a 3D object, another cube. And for this cube, let's put it over here on the side. And this one, let's use the black material. So again, in the included assets, there's this nice black material. There you go, it's completely black, nothing to it. So let's just use this as kind of a hider. So let's just scale it quite a bit and lift it up. Okay, so there it is, a black material right next to the wall. And let's put another one over here on the left side. And just like that. Can also put another one on the back there, even though I don't think the camera can see that part, but still, let's put it. So just put it like that and stretch it out. Okay, that's good. By the way, over here on the outside, it doesn't have to be perfect. It doesn't have to perfectly match. The camera is never going to see that position, so it doesn't matter. It only matters what the camera can see. And if we play like this, and if there you go, now that looks quite nice. If we want over there, we can get it together just a little bit. And we can also move the camera forward a tiny bit. So over here on this one, let's push it just a little bit to the left. Okay, and now on the virtual camera, let's play the game. And now here, if we want, we can push it up a little bit, something like this. So let's put it on this Z, so let's copy it, stop playing the game, and let's paste it just like that. Okay, so here's our game. And as you can see, with just this one tiny change, just adding some walls and a nice black outside, just with that, it already looks so much better than having some counters in wide open space. Now for another simple one, let's add some nice particles while the player is moving. So in the included assets, if we go inside the prefab visuals, over here is a nice one for player moving particles. This one, as you can see, is a particle system. So let's drag it over here into the world to see what it looks like. And as you can see, by default, it's actually not spawning anything. So I can make sure that this one is running and nope, nothing is spawning. So this is actually set up in a really interesting way, is that instead of spawning particles all the time, it only emits while moving. So if I click to move this object, there you go, the particles start emitting, and if I stop, they stop. So this one is definitely perfect for a player particle system. The way this is set up is over here on the emission. On rate over time, it is set to 0, so it doesn't spawn anything automatically, and it only has over here the rate over distance. So as it moves, it's going to spawn that number of particles. Then the other settings, they're all pretty basic. So there's some gravity, so they fall down, just like the stove counter particles. The simulation is over here on space, so that as I move, the particles stay behind. This is important. If I were to put that in local and I move it around, look at that, this is not what we want. We want the particles to essentially stay behind instead of following this transform. So that is why this change is super important. If that one is set to whirl and as I move, yep, the particles stay behind. Okay, great. And the other properties are all pretty basic. For the shape, it's a cone pointing upwards. Then for the size over lifetime, again, just a basic curve, constantly becoming smaller and smaller. And down here on the renderer, instead of rendering a quad, it's actually rendering a mesh, and it's rendering a sphere mesh. So that is just so that it looks a little bit better, I think, than just having a sprite particle. Okay, so that's it. So in order to make this work, really all we need is just attach it to the player. So let's find the player, make this object a child of the player game object. And again, let's also make sure to set all of this to 0, so the position on 0, 0, and 0. And there you go, just with this, that's all we need. If we test, here we are stopped and there are no particles, and as I start moving, yep, there you go, some nice particles around the player. Okay, great. Next, let's add a pretty obvious one, some kind of mini tutorial. We want a window to show the controls and the goal of the game, and wait for the player input before we start the countdown. So for that, let's go into our canvas, so let's show our canvas. And inside, let's create an empty game object, call it the tutorial UI. Let's drag this one above the game pause window so that it shows up behind it. Let's double click to center it, and let's press on the 2D button to go into 2D mode. Okay. Let's also hide those two windows so we can actually see what we're doing. So let's hide all of these. Okay, great. Now this one, first of all, let's stretch it to occupy everything. So put 0 on everything. Okay. Then inside, let's make a UI image for our background. Once again, let's stretch it, put it like this. And for this one, instead of black like we've used for all of our windows, let's actually leave it on white. Put it on an alpha of something like half, so something like this, just to be a bit different. Then on top of this, let's make another image, so let's make another UI image. And for this one, instead of stretching, let's give it a size, so let's put it on 1280 by 800. And for the image, I created a nice image for the tutorial. If we go inside the assets and then inside textures, yep, here is a really nice tutorial image. So let's just go ahead and use it. So on the image, let's drag it. All right, there's our nice tutorial image. So this has a pretty basic tutorial. So the recipes come in from the customers, then the player has to prepare the correct recipes and deliver them on a plate on the delivery counter. So just a very basic tutorial. And also over here, it's very important for the player to know how to actually play the game. So there's some labels for the controls, and now we're going to dynamically add some keys on top. So let's do that. Let's create an empty game object. Call this the key. Let's put it on a size of 40 by 40. Okay. Now let's go inside, and inside let's make an image. let's name this the background. And for the sprite, let's go with the included circle, so default circle. And for the size, let's stretch it to occupy everything, put it on 0, 0, 0. Okay, there's our nice key. So we have the background. And for the background, let's actually make it just a little bit darker. And let's also add just a nice shadow. So maybe 3 minus 3. And let's also make a nice outline. Let's put it on 2 by 2. Full alpha, so something like this, just to be a nice one, maybe 1 by 1. Okay, so that's just the visual. And then on top of it, let's add a text. And this one is essentially going to be the key. So let's put a key for the width and height. Let's stretch it to match the parent size, okay? Then for the font here, let's go with maybe just a 20. Let's put it centered down the middle. And also let's put it on bold. Okay, so that's our nice key indicator. So this is our key. And we're going to have the movement. So the movement on the keyboard is going to have 4 keys. So let's just duplicate. So 1, 2, 3, and 4 keys. Okay. Then on the gamepad, that one is actually not rebindable. So let's put this one as static. So let's just go inside the text, and just say left stick. And let's lower the font size so that it fits in there. Okay, great. Then for some more keys, we're going to have the interact action, then the interact alternate, and finally the pause action. Then let's just duplicate these to be on the other side. Okay, so these are all of our keys. Now instead of having key 1, 2, 3, this is very difficult to understand, so let's give it some proper names. So this is the key move up, then we have the key move down, then the key move left, then the key move right, then this one's going to be the key gamepad move, then we have the key interact, the key interact alternate, the key pause, this one is the key gamepad interact alternate, this one is the key gamepad interact, and finally the key gamepad pause. Okay, all of these, and since we're going to drag references to the text objects, let's also give those a name. So just copy, drop it with text, just like this. Okay, so those are all the names, so everything is nice and organized. Okay, great. Now let's make the script to run this. So our tutorial UI, let's go down into our UI scripts, create a brand new C# script for the tutorial UI. And let's attach the script. Okay. So first, let's drag references to all of our keys. We only need the text, so let's do a serialized field of type text mesh pro UGUI. Again, never make the mistake, always use the UGUI one if we're working in the UI. So the key move up text. So let's add all of these. Okay, these are all the references. Then over here, let's drag on and make sure to drag the correct ones. Okay, let's double check to make sure all the references are correct. Okay, they all seem correct. All right, great. And then over here, let's do pretty much exactly the same thing that we did over here on the options. So we need exactly this. So let's copy this. And over here, let's do just that. Let's do a private void update visual. And on this one, let's do pretty much this. So the key move up text. And on this one, you get binding text of move up. Yep, let's just do all the others. Okay, so those are all the bindings, that's great. Now let's go over here on a private void start. And on start, let's update our visual, all right. And also let's make sure this updates just in case the player rebinds something from the pause menu whilst the tutorial is still visible. So we just need to know when that happens. So let's go over here onto the game input and make a nice event. So public event, event handler. Let's call it on binding rebind. Okay, we have this event. And down here, when we have our rebind binding function, we do this, we rebind, and over here, let's invoke this event. Okay, just like this. So then on tutorial UI, let's go into the game input, the instance, on binding rebind. Let's listen to this event. And as always, let's rename this. So let's put it game input. Okay, when this happens, let's simply update the visual. Okay, that's it, pretty simple. So let's test and see if the inputs are correct. And if there it is, we do see it correct. So we've got WAS, we've got E to interact, F, and over there we've got the gamepad. Okay, great. So all the buttons are correct. All that's left is the show and hide. So over here, let's make the usual two functions. So private void show and a private void hide. And for these, game object set active. And this one is going to be into false. And this one is going to be true. Okay. So for show, up here on start, let's actually show it by default. Even though it's actually already going to be shown, but still, okay. Then for the hide, this one we want to hide when we press the interact action. However, when that happens, we don't want just this window to hide. We want the Kitchen Game Manager to change the state. So over here on the Kitchen Game Manager, we currently have the waiting to start, and that one actually has a timer. So we count down the timer and then we start. Whereas right now we want it to be based on player input. So let's modify this to not be based on timer. So let's just get rid of this timer. And now let's see all these errors. So on waiting to start, we are not going to count down any timers. Instead, let's listen to the game input. So game input, let's listen to the on interact action event and rename this to the game input. Okay, so when we have this event, when the player presses the interact action, let's check if the state, if this one is on waiting to start. If so, then let's modify the state. So let's go into state and we're going to go into the countdown to start and let's trigger the on state change event. Okay, so that's it. So we're only going to change it on the player input and nothing over here on the update. Then for hiding the tutorial over here, one approach would be to listen to the interact action and hide it. But I think it makes more sense for this to only listen to the Kitchen Game Manager state. That way, if we wanted, we could also modify how this one changes the waiting to start. So let's listen to the state. Over here on tutorial UI, let's go into the Kitchen Game Manager, the instance, and let's listen when the state changes. So here we are going to check if the Kitchen Game Manager instance, if it is on the countdown to start active. So if the countdown is active, then we're going to hide this. Okay, so that should do it. Now let's just do one more small thing. The delivery manager is currently spawning a recipe whilst we're still reading the tutorial. That's not quite right. So let's go over here on the delivery manager. And right now this one starts off at 0F and starts counting it down right away. Instead of always doing it like this, let's just make sure that we only spawn a recipe if the game is playing. So that's super simple. Over here, Kitchen Game Manager instance, is game playing? If so, then we are going to spawn a recipe. And let's do the same thing on the plates counter. So let's go in the plates counter. So here we are on the plates counter, so we count down timer and spawn some plates, but let's also make sure we only spawn plates if the game is playing. Okay, so with all of this, let's test. And right away, here we are, we can see our nice tutorial teaching the player how to play. Okay, great, here we've got the controls, everything, and we're currently waiting for an interaction. We can see over there, plates are not being spawned, and recipes are also not being spawned, but as soon as I press the E key, and yep, there you go, the countdown starts playing, and we've got everything else, and yep, there you go, the game starts. And after a while, yep, we've got plates, and we've got recipes. Alright, awesome! So next, let's polish the countdown visual. Right now, it's pretty basic, it's just a static number, so let's add a nice animation to it. Let's go inside the canvas, let's find the countdown UI, so the game start countdown, okay. So here it is, we just have some basic text. Now let's go into the main game object, and let's add an animator component. Then let's create a brand new animator controller. So let's create a new, down here, an animator controller for the countdown UI. Over there, let's assign this controller. Okay, now let's open up the animation window. So window animation, open up the animation window. Okay, let's create an animation clip. And over here, let's name this the countdown UI number pop-up. Okay, that's great. Now for making the animation, we want to basically make it shake and also make it fade away. So one very useful component is the canvas group. So over here, whilst on the parent, let's attach a canvas group component. This one is a really useful component. In this case, the main benefit is it lets us easily animate the alpha. So let's go ahead, enter on recording. Let's go into the frame just before 1 second. So let's go into 60 frames because we are on 60 frames per second. Over here, let's record a normal keyframe. So let's modify the scale a tiny bit just to record it, and let's reset it back to 1, okay, just to record the keyframe. Then for rotation, let's rotate it on the Z, then put it on 0. Again, just to record the keyframe. Okay, great. So now we can go back into the first frame. And over here, let's first make it smaller. So for the size, let's put it on 0.6. Then let's rotate it to the left. So let's put 17 over here on the Z rotation. Okay, like that. Now let's move up by just 3 frames. So on frame 3. Over here, let's make it quite a lot bigger. So let's put it on 1.3. And let's rotate it to the opposite position. So minus 17. Okay, that's great. That's a nice start. Now let's put it on frame 10. And over here, let's set the rotation to 0. And for the scale, put it on 1.1. Okay, so now finally over here on frame 50, let's set the alpha onto 1. And then on 1 second, let's put the alpha on 0. Okay, so let's preview. And if there you go, a nice simple animation. Okay, so that was great. Now we just need to play this when the countdown happens. So let's stop recording. Let's go inside the animator controller. So here it is. We've got our number pop-up. And we basically just want to play this animation whenever we want. So let's put it and make a transition from the any state onto the number pop-up. On this transition, let's make sure we have no exit time. And for the settings over here for duration, let's put it on 0 so that it's instant. Okay, great. Now, obviously, we need a condition. So on the parameters, let's create a brand new trigger. Call this the number pop-up. Let's select that one and trigger it on this trigger. Okay, great. So now for handling this logic, here we have the usual question. So do we put this visual logic on the same UI script, or do we separate the animations from the UI? For me, I find that the UI is usually part of the visual, so sometimes I like to mix the two, and sometimes I keep them separate. It really depends on a case-by-case basis. This visual is so simple and so connected to the actual UI logic, so over here let's put them together. So let's open up the game start countdown script. And over here, let's first grab the animator. So private animator for the animator. And on private void awake, let's just get the animator and just get component of type animator. Okay, so we have the animator. Now we basically just need to keep track down here where we're modifying the text. We're doing this on every update, but now we need to know when this number changes. So let's basically just keep track of the current number and the previous number. So first of all, over here, an int for the countdown number. And we're going to get this. So this is our countdown number. And over here, we set it to string. Okay, and we just need to use a different function. So instead of cl, let's use cl to int, just to convert the output into an integer. Okay, great. So we have the countdown number. Now we just need to know if this one is different from the previous one. So let's go up here. Let's define a private int for the previous countdown number. Then when we go down here, we've got the current countdown number. Okay, then just check if it's different. If it is different from the current countdown number. If so, then let's update it so the previous one becomes this one. And now let's fire off the animation. So let's go into the animator and set the trigger. And again, we don't want to use strings, so let's go up to the top of the file, make a private const string. Let's call this the number pop-up and number pop-up. Okay, so we have this, and down here we just set this trigger. Okay, so that's it, pretty simple. And just for fun, let's also add a nice sound effect. So let's go over here onto the sound manager and let's make a function to play sound. So just like we did over here for the play footstep sound, let's make another one. For this one, let's call it play countdown sound. And for this one, let's not receive a volume or position. And we just play, let's say, just the warning sound. So just that one on vector3.0 and with the current volume. Okay, so we have this function. And then down here, just go into sound manager instance and play the countdown sound. Again, we could refactor this code to separate the UI logic from the animation from the sound. That is one approach. And it's actually one thing that we're going to do in the next polish stage. But this one is also a possible thing, since the UI is always so directly connected to visuals. Okay, so with this, let's test. So here in the options, let's just make sure that we have our sound effects. So let's make sure they are playing. Okay, great. Now let's go ahead and play. And there you go, we have our nice countdown number. And there you go, it looks great. So it looks great and sounds great. All right, awesome. As you can see, just by adding a simple animation and some simple sounds, it already looks so much better. Now, the next thing we want to polish is on the stove. So let's go into our stove, back into our counters, back into 3D and zoom in over here. Okay, let's also make sure that we hide the canvas just so we can play around this. All right, great. So there's our stove. And for this, we want to add basically a warning icon and a nice sound when the meat is about to burn. So let's go inside the stove counter prefab, okay? So now inside of this, we already have a nice generic progress bar UI. And like I mentioned, if you want to get some more custom behavior, you can combine a generic bar like this one with some specific component. So that's exactly what we're going to do right now. So over here, let's create a brand new canvas. As usual, let's make it a world space canvas. For position, let's put all of this on 0. Let's just lift it up by a bit, so set it on a Y of 3. Okay, great. Then let's add our super useful look at camera component and make it camera forward. Okay. Now inside, let's go ahead, create a new image. Let's put it on a size of 0.5 by 0.5. Okay, just a nice square. And for the sprite, there's a nice warning image in the assets. So it's this one. Here we have the warning. Okay, great. Basically, we want to show this when the meat is about to burn. So let's make a script to run this. And on the canvas, let's give it a proper name. So let's call this the stove burn warning UI. Okay, so let's make the script to run this. So a new C# script with the exact same name. And over here, let's attach a script. Okay, great. So now the first thing that we need is obviously a reference to the stove. So let's make a serialized field private for the stove counter for the stove counter. Okay, here in the editor, let's drag the reference of the stove counter. Okay, great. So now we basically just need to know when the food is about to burn. And for that, we can actually listen to the onProgress event. So let's do a private void start. And on start, let's go into the stove counter. And let's listen into the onProgress change event. Okay, so we have this one. And basically, we're going to want to show this element. So let's define a bool show. We're going to want to show this when the progress normalize is above a certain amount. So let's define a float for the burn show progress amount. And let's say on 0.5. So on this one, we show it. Except obviously we don't want it to be shown when the food is just cooking. We only want it to show when it's about to burn. So that means we also need to check the state on the stove counter. So let's make a function to check if we are in the state that we want. So we're here on the stove counter. Let's go down to the bottom. And let's make a public bowl is fried. And over here we just return if the state equals state.fried. Okay, that's great. So now here we're going to show if the progress is above 0.5 and the stove counter is on the fried state. All right, so that's the logic that we want. Then we just want to show our hide. So let's make the usual functions, private void show and a private void hide. And just do game object set active into either true or false. And over here, if show, then let's call the show function. And if not, let's call the hide function. And of course, on start, let's start off as hidden. Okay, that's it. Let's test. Just over here in the editor, make sure the reference is dragged. And let's save the prefab, go outside, and hit on play. And yep, right away, there's no element. Okay, great. Now I place it. And yep, while it's cooking, there's no element. And now once it's on the halfway point for burning, and if there you go, we've got the nice warning. Okay, awesome. So now that this is working, let's just add a nice animation. So once again, let's go inside the stove counter and on the burn warning UI. Let's add an animated controller. Then let's actually create the animated controller. So let's create a brand new animated controller for the stove burn warning UI. Then let's assign it, okay. And over here on the animation window, let's create an animation. Let's put it on the same folder and call it, for this one, let's say flash. We're going to make it flash. And then again, for making it flash, let's use the same component that we used a while ago. So let's add a canvas group. So here it is. Now we can play around the alpha, so super useful. Although I should say that at this point, since we just have a single image, we could just record a change over here on the alpha for the image itself. However, one place where this component is super useful is if you have multiple images. So if over here I duplicate this one and I put it off to the side, if I change the alpha on one of them, then obviously it only affects that one. But if I go over here and I modify the canvas group, that changes the alpha for both of them. So if you have a group of images, then using the canvas group makes it super simple. So anyway, so here we have just our image. Let's go ahead and record. And let's say we start off on an alpha of 0, then after 10 frames, go into alpha of 1, and after 20 frames, back into an alpha of 0. Okay, so that's it, a super simple, very basic animation. We don't even need any logic since we just want this animation to play non-stop. So that's great, that should be working. Now let's add some sound. So for that we could make another script, but already on the stove counter we already have a nice sound component. So let's open up this script, the stove counter sound. So this is basically where we're playing or stopping the sizzling sound. So over here we can just add the warning sound. We're going to play the sound just like we have over here for the burning UI. So let's actually copy these same components. And over here let's paste it. So for this one, instead of show, let's give it a proper name. So play warning sound, except it's not on state change, so let's actually listen to the other one. So stove counter on progress changed. Let's listen to that one, and it's on that one that we use this. Okay, so we've got that one. And then for playing the warning sound, we're going to want to basically play it every certain amount of time. So let's make over here a private void update. And on update, let's just define a private float for the warning sound timer. And so down here, we just count it down as usual, time.delta time. And if this one is under 0, if so, then let's reset it. So define a certain maximum. Let's say 10 times, or maybe just 5 times per second. That should be good. So we have this, but obviously we only want this to run if we should be playing the warning sound. So let's actually save this one up here. So private vol for these play the warning sound, and then we set it on this one. And down here, let's just go, and we're only going to run this if play the warning sound. Then we're going to run our timer logic. All right. And then over here, all we need is to play that warning sound. So let's actually go into the sound manager, and just like we added the countdown sound, let's add another one. So let's say the play warning sound, and for this one, let's receive a vector 3 for the position, and we're going to play the warning sound on this position. So now over here on the stove counter, let's go into the sound manager, the instance, and let's play the warning sound, and pass in the stove.transform.position. Okay, that should do it. So we now should have a nice warning sound, and over here we should have a nice animation on the burn warning UI. So let's see both of those. Okay, so let's pick up some meat and drop it. And right now it's cooking. Okay, great. And once it gets to the halfway point, if there you go, now we have a nice warning sound. All right, awesome. Let's just add one more tiny thing. Let's make the bar itself also flash red when we're about to burn. So once again, let's go inside the stove counter. And on the progress bar UI, let's add a nice animator. And let's go ahead and make one. So let's create a new animator controller. For the stove burn flashing bar, let's go ahead and assign it. So it's the one on the progress bar. Let's add the stove burn flashing bar. Then on this one, let's create new animation. Let's go inside the assets, animations. Let's make one and just call it idle. For this one, we're going to want the exact same color as the normal color. So let's go into the bar and set the color. Just save a keyframe over there. Okay, so that's what we want. Now let's make another animation. So let's stop recording and let's actually duplicate this one. So duplicate it. And for this one, name it flash. Now, of course, we need to add it to the animator controller. So let's go over here and drag it on top. Okay. Now for the animation, let's select the flash. And for this one, let's go ahead, click on record. Let's start off on this one. And after a few frames, so let's say maybe after 10 frames, let's flash in red. And after 20 frames, let's copy paste the same frame. Okay, so that's our nice flashing bar. Now let's just set it up. So let's go into the animator. And over here, we're going to have a transition from that to flash and from flash back. Now all we need, of course, is an animator to control this. So let's make a new animator parameter. Let's make it a boolean and call it is flashing. And again, make sure to be careful with case sensitive. Okay, so from idle into flash, let's go ahead, remove the exit time. For duration, make it instant, so 0. And for the conditions, when that one is true. Okay, great. And for going back, once again, same thing, so instant. And let's make the condition when it's false. Okay, that's it, super simple. Now let's make a script to run this. So let's go ahead, create a brand new C# script for the stove burn flashing bar UI. Let's go ahead and add it to the bar. So that's the flashing bar UI, okay. Over here, let's do pretty much the same thing that we did on the other one. So let's go over here onto the stove burn warning UI. Let's actually copy exactly this. So let's go on this one and paste this one. Then back here in the editor, let's drag the reference to the stove counter. And over here, the logic is going to be very, very similar. So the only difference is we have an animator. So the animator, and we're going to grab it on private void awake, animator get component of type animator. So we have the animator, then let's define the parameter. So private const string for the is flashing, and let's set it is flashing. Okay, we have our parameter. And now down here, instead of showing and hiding, let's just go into the animator in order to set a bool. And the bool will be the is flashing, and let's set it based on show. So either we show or hide, and we actually don't need these functions. And by default, of course, let's leave it on false. Okay, so that's it, super simple. Let's test. Just make sure to save the prefab and hit on play. Okay, let's go ahead and cook. So let's pick it up and drop it. All right, so it's cooking. Let's wait for it to be burning. And as soon as it gets there, Yep, there you go, we've got a nice warning, a nice flashing bar, and a nice sound effect. So all three warnings making our stove much more polished. Alright, awesome! Now just for balancing, let's play around the timers. So let's go into our scriptable objects on the frying recipe SO. Let's make this one take 5 seconds. Then on the burning recipe, for this one, let's make it take 6. And finally, let's also add another stove. So let's take our stove counter, duplicate the prefab, let's put it over here. So rotate it to the side, let's get rid of this one, and put this one right in there. So on 7.5, 0, and -1. Alright, so we now have 2 stoves. I can put one cooking, put another one, and I can start cutting down some cheese. Start cutting, and before they start to burn, let's actually here. There you go, that one is about to burn, so let's pick it up quickly. And that one is actually gonna burn, but I got it. Okay, great. Alright, awesome, everything's working great. Now for one more polish element, let's make a nice visual when we deliver either a correct or incorrect recipe. I think it would look good as a world canvas on top of the delivery counter, so let's do that. Let's over here find delivery counter, let's go inside the prefab. And now in here, let's create a new UI canvas. Let's name this the delivery result UI. And as usual, let's make this a world space canvas, so put it on world space. And for the position, let's actually lift it up, and then we're going to make it look at the camera. But just like this, it might actually go inside the wall, so let's put it over here to the side a little bit. So let's put it on this position, so on the X of -1.6, on a Y of 3, and on a Z of 1.2. Okay, that's the position, so right there. That is going to be looking at the camera. Now inside, let's create a new UI image. It's going to be our background. And for the size, the width and height, let's put it on 2.2 by 0.9. Okay, that's our background. For the color, let's tint it in a nice green. So let's put it something like this. Then let's also add a nice outline. Let's put it on full alpha. And for the size, let's put it on 0.1.1. Then let's also add a nice shadow component. For this one, leave it on half alpha. And let's put it on 0.2 and -0.2. Okay, so that's a nice visual. Now on top of it, let's create a new UI text. Let's call it the message text. And for the message, we're going to say something like delivery and then underneath success. Let's put it on a width and height of 0. Let's put it on a super tiny font, so let's say just 0.25. Let's put it in bold and put it down center and get rid of wrapping. Okay, that's it. Let's just push it a little bit on the left side, so on -0.32 on the X. Okay, and now next to it, let's make another UI image. For this one, call it the icon image. Let's put it with a size of 0.5 by 0.5 and put it over to the right side, so on an X of 0.7. Okay, and now for the sprites, included in the assets are 2 nice sprites, so there's a nice cross for when we get it wrong, and there's a nice tick. Okay, so that's the setup that we want. Now on the delivery result UI, let's go ahead and our look at camera component. And for this one, let's go different. So instead of the camera forward, let's go ahead with the look at inverted. So there it is, this is our setup. Now let's make the script to run this. So let's go ahead, create a new UI, new C# script for the delivery result UI. Let's attach the script and open. Okay, so now here let's make serialized fields for our elements. So a serialized field, first of all for the background image, and this is actually going to be of type image. Image inside Unity Engine.ui, okay, our background image. Then we're going to have another one for the icon image, and we're going to have another one. This one is a Text Mesh Pro UGUI for the message text. Okay, let's save. Okay, so let's drag the references to the background, the message text, and the icon image. Okay, great. Now over here, let's listen when a delivery is delivered. So let's make a private void start. Let's go into the delivery manager, the instance, and we have all of our nice events. So we've got a success and a failed, so let's listen into both them. So both the success and on the recipe failed. Let's listen to all of these. And as always, let's write good clean code and rename this. So delivery manager on recipe success. And for this one is the on recipe failed. Okay, we have both of our events. So now over here, it's actually going to be very simple. We just want to play around the text, the icon, and the background color. So for example, when we fail, let's go and we want to set the background image to about a red. So for defining the color, let's actually go up here and define a color for the success color. And we're going to have another one for the failed color. And then for the sprites, let's also have that. So a sprite for the success sprite and another one for the failed sprite. Okay, those are all the elements. So over here in the editor, let's just set them. So for the success color, let's actually use the exact same color. By the way, here's a quick tip. If you go up to a field, for example, like this one on the color, you can right click and copy and then go into delivery results, and over here right click and paste. There you go, the perfect color. Then for the failed color, let's go with the red, maybe a bit darker. And also importantly, make sure you set the alpha to full, okay? So we have a red nice like that, okay? Then the success sprite, this one is going to be the tick, and for the fail, this one's going to be the cross. Okay, those are all of our elements. So now over here, when we fail, let's go into the background image and set the color, and let's put the failed color. Then for the icon image, let's set the sprite to the failed sprite. And for the message text, let's set this one for delivery, and then failed. By the way, this /n, this means a new line. So over here, let's just set the text on this one. So it essentially means that it will write delivery, then new line, and then failed underneath. Just make sure you're using the / and not the /. So use the backwards one. There you go. There's a new line. Okay, so that's the on recipe failed. And now on the recipe success, let's use the success color, the success sprite, and over here, delivery success. Okay, so that's great. That should be working. Now just one more visual thing. Let's add a nice animation. So just like we did previously, let's go over here. Let's add an animated component. Let's create an animation for this one, for delivery result UI. So let's go up here, create a brand new animated controller for this, and let's go ahead and assign it. So delivery result UI. All right, now let's make an animation. So this delivery result UI, let's call it just pop-up. And for this one, let's do just like we did for the numbers. So let's scale and rotate it. However, if we rotate, that's actually not going to work. That is because we have the unlock at camera, and this one is already going to be setting the rotation. So we would end up with this script fighting the animator for the rotation. So that would mess things up. However, one nice and simple solution to this, basically we just put this inside another game object. So let's create a new game object and let's put it inside. Let's an empty game object for delivery result UI, and then look at camera. So we have this one. Now the reason why I created it inside is that so over here we can set everything to 0. And now with that one all on 0, we can go ahead and drag this outside of this object. And there you go, that one keeps the exact same settings. And now on this one, we can add the unlock at camera component and set it up just like we had, so the unlock at inverted. And now on this one, we're going to make a child of that one. And there you go, now everything is on 0, exactly as it should be. And on this one, we can get rid of the unlock at camera. And now we can indeed play around the rotation. So for the animation, let's just go ahead and set it. So for this one, let's go up to 1 second. And let's record a keyframe on a scale of 1 and on a rotation of 0. Then let's go back into the beginning. And for this one, let's scale it backwards. So maybe something like this, maybe a 15. Let's put it quite a bit smaller. Then let's go up by 3 frames. Let's put that one on -15. So rotation on the other side and put it quite a bit bigger. And then on frame 10, put it on, say, 1.1 with a rotation of 0, just like that. So there you go, there's a nice pop-up. And for the alpha, let's also go over here into the 50. And let's just add the canvas group. Let's set this one over here is on 1, and then we scroll it down to 0. Okay, so that's our nice animation. Let's stop recording. Let's open up the animated controller, and over here, let's make our nice animations transition. So transition from any state into that one. Let's make it based on a trigger. Let's call it just pop-up. And for this one, this says no exit time, duration of 0. And let's go when the condition when we have this trigger. Okay, so that's it. Although one thing, by default, this animation is going to loop. So let's just go ahead, we can select the animation. And over here, let's just untick loop time. So that way the animation will not loop. Okay, so that's great. Now let's go into the script. And over here, let's get our animator. So private animator, private void awake. Let's get the animator, just get component of type animator. And let's define over here the private const string for the pop-up. So we have this, and then when we have either fail or success, let's just go into the animator and let's set the trigger for our pop-up, both up here and over here. Now we just have obviously one issue, which is that it starts off as visible. We don't want that. So over here, we can just do game object, set active into false in order to hide it. And when we get either of these, let's set it both to true. Then afterwards, the animation will make it invisible. So it will still be active, but it won't be invisible. So that's fine. So just with this, everything should be working as we want. So let's test. Let's just make sure to save it and go back. Okay, so here we are. Let's try delivering an incorrect plate. And there you go, got a delivery failed. Okay, great. Now let's try delivering a correct one. So someone wants a cheeseburger. So let's cook it, slice some cheese. Let's get some bread. So bread, cheese, and pick up the burger and deliver. And there you go, a nice delivery success. All right, awesome. Okay, so with these handful of changes, you can already see how we made quite a big difference in our game. We didn't do anything to change any core mechanics. We just made what was already there pop out. We added a nice visual boundary to make the map look nice. We added some nice particles when the character is moving. Then we added a nice tutorial and controls right as the game starts. We also added a bunch of effects on the stove, so it flashes, has a warning and some sound. And lastly, we also added a nice pop-up when delivery is delivered, whether correctly or incorrectly. Now of course, we can always keep polishing the game until infinity. There's always more small things you can add to polish the game just a little bit more. But at this point, I'm very happy with what the game looks like. So after all this work, let's go into the next lecture where we're going to play our game from start to finish and see what we've done. Hello and welcome, I'm your Code Monkey. In this lecture we're going to look at all of the work that we've done and have some fun playing the final game. Okay, so here we are in our nice starting main menu. It's simple but it works. I actually think it looks pretty good. So we have our main menu working and we also have the unloading system that we made. So as soon as I click on play, there you go, loads the unloading scene and here we are on the game scene. So we start off with our really nice tutorial window, and down here we have the controls. Of course, all of these are dynamic, so depending on if the player rebinds or something, this one is going to update. So we can look at this window for as long as we want. The game is paused in the background, so it's on a paused game state. Then whenever we're ready, we can interact. So again, that's the game input class, listening to the input. And again, all of the code in here is really nice and clean. So when we press the interact key, the tutorial isn't directly listening to that, but rather the general kitchen game manager. That main state machine is the one listening to the input, and this one is listening to that state. So all our logic is very well organized. All of the elements only listen to the things that make sense to them. So anyways, here we have tutorial, let's interact, and there you go, we've got our nice game start countdown, some really nice animation, really nice sound, and yep, here we are. Then we've got our clock showing the game time, and on the left side we can see our recipes. Once again, all of the elements, they're all dynamic, they're all spawned randomly, and the icons for all of the recipes, they're also all dynamic. So over here we have the character control that we built, we have the collisions that we implemented, and of course we have the raycast testing for interaction, so we can identify all the objects in front. Let's begin delivering some recipes. So for example, we need to cook some meat, so let's go ahead, put it on the stove. So here is the really nice state machine that we built. So we've got all of the various states, we've got the visual completely separated from the logic, so everything is really nice. And of course here we have the nice burning elements that we added in the polish lecture. So that one is burned, so let's go ahead and use the trash bin to get rid of that. So let's go ahead, cook another one, and let's make a cheeseburger. So let's put some cheese, let's listen to the alt interaction key, and we can slice the cheese. We can pick up the meat, pick up the cheese, then also pick up some bread, and deliver the recipe, and there you go, our nice polished visual. Alright, awesome. So here you can already see everything that we've built. The character, the physics, the logic, the input, all of the UI elements, all of the world UI elements, all of the various counters and how they are all prefab variants, all of the plates, the separation between the visuals and the logic, the separation between the sounds and logic, all of the polish elements that we made, over there the nice shader graph that we made. Then of course all of the basic things that a lot of tutorials won't teach you, like for example how to make a pause menu, how to make the options, how to modify the sound and music volume, how to rebind the keys, and so on. So with all that, here throughout this course we'll learn how to make a really nice game with lots of interesting interactions, which you can now apply to any kind of game, any kind of genre you want. So like I mentioned in the very beginning, you can take pretty much what we made here, which is really just a character controller and a bunch of interesting interactions. You can take everything that you've learned here and make something on a sci-fi space, so like for example make something like Among Us, you can make something like FTL, or perhaps make some kind of survival crafting game. So all of the interactions you would have like resource nodes in the world, then you can interact to gather those resources. So with that you could build something like Rust or Minecraft or Don't Starve. So hopefully in this course you'll learn a ton that you can now apply to your own custom original projects. And if you've made it this far, then congratulations! Let's go into the next lecture where I'll give you my closing thoughts. Hello and welcome, I'm your Code Monkey, and congratulations, you have completed this course! Awesome! Seriously, congrats. Looking at the stats on my courses, very few people stick with it until the very end. So if you're hearing this, then that's excellent, you're on the top 10%. It means you are serious about learning game development, and I genuinely hope this course has helped you on your own game dev journey. Throughout this course, you'll learn about the basics of Unity and C#, you'll learn how to make a character controller, how to do a physics raycast and use that for both collision detection and identifying objects to interact with. You'll learn about C# interface and events, two extremely useful C# features. You'll learn about scriptable objects, how to use the new input system, shader graph, and tons more. And the most important thing of all, you'll learn how to build a relatively complex game while writing good, clean code. I really hope that's the main takeaway you'll learn from this course. Learning how to write better, high-quality code, learning how to refactor, how to keep the visuals and the logic separate, keep the UI decoupled from the logic. Learning all those things has now made you a 10 times better developer than when you started. So I really hope you enjoyed learning all of that. Let me know in the comments what was the most important thing you'll learn throughout this course. I really hope this was very fun and very educational. If you enjoyed my teaching style, check out my other courses. I really think the turn-based strategy course would be excellent for you right now. It dives even deeper into some advanced topics, and since you've watched this entire course all the way, you now have all the knowledge needed to follow that course. It will help you really solidify all the knowledge you gained, especially everything related to writing good, high-quality, clean code. And since you use Unity, check out my Ultimate Unity Overview course. It covers lots of tools and features of the engine, so you can really use all the tools at your disposal to make any game you can think of. Alternatively, if you like visual scripting, I have a course on that, or learn how to make a really nice Builder Defender game. And definitely make sure to wishlist my upcoming Steam game, Total War Liberation. I will be posting devlogs, and in those you will see how the code that I use in my own Steam game is on the same level of quality as what you learned in this course. Okay, so that's it for me. This course was a ton of work, so I genuinely hope it helped you a ton on your game dev journey. Thank you so much for watching, and I'll see you next time.